Okay, it says we're live. I see. How did we see you, Patrick? That was cool. It's not moving, but cool. Knorke. Okay, we just may have to begin. Cool. So, welcome to Eurobhyvecon 2025 in Zagreb. I'm delighted by the turnout. I'm delighted by about a half dozen people volunteering a little extra money for this free of charge event to cover costs, about 210 euro. That's amazing. Thank you. Thank you, thank you. Thank you everyone, Ivy, Christoph Provost, everyone who's improved the bridge support. It's faster, it's awesome. There's Netgraph, there's all sorts of cool tools. SRIOV is getting a lot of attention. So you have an enterprise grade NIC, you hand it out like one hopefully hands out cores on ARM64, you hand out hardware resources, very cool. State tracking. This has been a challenge to jails, it's been a challenge to virtualization. You sit down at a VM and wonder, how did I get here? What's the backing storage? How was it launched? There's not a whole lot of transparency on what the VM is doing, so that's an opportunity for many great things. And no VM is an island. They require networking, they require storage. They need those prepared in advance before you boot, or very bad things happen. And you wonder, like, why can't I see the world or see my VM? So the traditional Unix model of stuff starting very linearly once is a challenge to virtual machines. Live migration, everyone wants it. There is progress that we will discuss very shortly. And of course, a budget. My work's been out of pocket, and that's why I'm so grateful leading with the fact that people have added a donation to their participation today, because that helps cover costs, covers lunch specifically. It covered coffee and other stuff from the Family Mart in Tokyo, and on. But there's been this weird secrecy. I don't get it. Stealth startups, secret chat channels, some of that's FreeBSD, some of that's just open source in general, secret funding. And my favorite simple story there is that a company doing proprietary OS on FreeBSD as their new product threw a whole bunch of money to Bangalore to do 386 support, meaning 32-bit i386 support. And they got nowhere. And John Baldwin probably did it on a weekend because he needed it for debugging i386 kernels. So communicate. It's invaluable. It is absolutely invaluable. So stealth open source, I'm calling it, maybe it's a better term, but it's not the flex you think it is. In fact, altogether now, stealth open source is not the flex you think it is. I don't know if we should make t-shirts, stickers, banners, whatever, but it's just, it has not helped Bhyve. That's, I think, what's been getting to me. It's like, well, wait a minute, there's all this exciting, there's this money and this stuff and all these startups and honey and just stuff. Some of it trickles down, but not always. And technical debt generally is downstream. Upstream is awesome. FreeBSD is actually really well thought out when it comes to what do we keep? Do we throw stuff out? Do we just keep moving forward? And they've kept moving forward for decades. And I'm sure some of you were in the Dev Summit. It takes enthusiastic discussions of like, well, what compromises do we make to keep it going forward in a way that satisfies the needs of so many people? So I really like the BSDs, if it's not obvious, the model of the license, the development models, the code tree from Kirk and company at Berkeley. It all is just logical, and thank you everyone who's helped make that possible. In the spirit of transparency, there were secret Bhyve calls back in the day, and the developers discussed important secret stuff, and then they petered out for whatever reason. And so, as many in this room know, there are production user calls, 3 a week on the trifecta, on jails, OpenZFS, and zones, and Bhyve. You are all welcome to be there. Many of you have been there. Show of hands, including Katja, Hans, the Patrick, the VV, Jan, you very present, DCH and company and all. And thank you, Greg. I think that cadence is important. It's a major investment on everyone's part. It's not been financially my best judgment, but it just has to happen. And here's the secret. The agenda is open. If you want something discussed, slip it on there. And if it's interesting, we'll discuss it. You can just watch the video. So you don't even have to attend. It's great. We have lots of flies on the wall, and that's absolutely welcome. I think openness is absolutely critical to moving forward, because that's what got us all in this room today. Planning this event was all done in the open. Funding it is in the open. It's, I think, the best match for free software. And I do want to keep BhyveCon free of charge, always has been. Thanks again for those who donated, but hey, it's open. So, project incubation. Jan, how long did it take us to all to fully understand the process supervision challenge? Like a multi-year discussion, and we've had multi-year discussions on ZFS headers in the base OS so that third-party software can build against it. And it's super inside baseball, it's super low level, but these conversations have to happen. And so often, we all have a gut sense that something's suboptimal, but we don't know what the answer is. And having people vocalize that challenge they're facing, the code they're working on, having a subject matter expert describe their own project is probably more valuable to them than us, despite the appearance of the opposite. So thank you everyone who has been a part of that. It's effective, it has results. Communication, communication, communication. If you want to support any of this, there's BSD Fund, something I've had since 2011 and announced in Mars and EuroBSDcon. Any ZFS users here? Any one or two? Okay, show of hands. Yeah. There is a user and developer summit in Portland, Oregon next month. You are cordially welcome to be there. It was a blast last year. It's a bit like this event, but on steroids with things like Argentinian barbecue and other fun stuff. So I hope some of you can make it to that. From the calls, meeting weekly and taking an idea and just exploring it and re-exploring it and clarifying and asking and that got the 9P server support, which was sitting there from FreeNAS 10 years earlier, but just never quite reached completion. We got it over the finish line. There was a GSOC project for MAC filtering for jails. The MAC address, well, if you have a jail, you probably just want to make it look unique to that. The project was stalled from the documentation, not the code. Luckily, the developer was still around and was happy to clean it up and get the feedback they needed from those who are native English speakers in this case, and that got across the finish line. Hans took a little fundraising and we got the TPM work in. It's a lot of baby steps, but with something, you know, a tool that has a different priority for every different user, well, we just kind of polish each little corner of it and keep it going. I consider BhyveCon fair game for jail topics and zones, and we may get to that later, but right here, right now, Jamie, the official maintainer of jails, is making some great progress on KQ support. I mentioned the networking and storage that all make something virtual work, because it's an island without that. Kernel notifications, like, hey, did your storage appear that you'll need? Jail descriptors, back to the whole problem with Bhyve of like, I sat down at a virtual machine, how did we get here? Well, the more you can describe a jail, be it through the file system like descriptions, and Jan maybe can elaborate on this later. I just get the geeks talking. K-event support, there are open reviews. This is a text right out of them. Jamie, the jail maintainer, yes, Mecca?
What's the difference between the first and the third?
The first and third?
Yeah.
They're in the reviews. Take a peek. I can bring them up later.
I mean, K-event is KQ, basically, so.
Please, Jan. Yes, they're all related.
So, apparently the first one is tracking a jail by its jail ID using K-event. The second one is adding descriptors so that you can have a descriptor reference a jail. And the last one is adding K-event support through the descriptor. Yeah, I get used to pulling, needing the file So
Let's touch on that after the official discussions and, yeah, explore that. Jamie, bless his heart, is in Oregon, but I discovered that in Ottawa. He's like 40 minutes from where I live. That was a pleasant surprise. He was on autopilot. He would fix bug reports as they came up, but there was no user feedback on jails. And he's not against expanding jails, but no one was asking for anything. So just bringing people to the table, describing the real world needs. Thank you, Doug Rabson and DCH back there on massive OCI progress and the Enterprise Working Group. It's just bringing people together, and wow, it's exciting what is coming out of that. So here's the agenda. We can be flexible on that. Lunch is probably the most firm thing there. Speaking about funding advancements for things that nearly everyone wants, Hans will discuss his CPUID work and a project that happens to be the foundation for live migration, like you see on other operating systems. Years ago, the calls avoided a hard fork of illumos Bhyve and FreeBSD Bhyve. So Hans can enlighten us on what needs to happen to keep them machine independent, OS independent, and then machine dependent. We'll take a break, probably compress it to save time. Alexei will join in remotely about GPU pass-through. That's been a holy grail that people have wanted for years, and he's taught the groups, the meeting call groups, more about the famous GPU reset bugs that every system seems to have, and he will talk quite a bit about that. It's delightful to watch his progress. And does anyone know Alexei? He just showed up on Discord and is doing the right thing at the right time and sharing notes and has jumped in and is doing amazing work. At 14:30, some folks will head off to the Nikola Tesla Museum as announced at the Dev Summit, but Haizam will join and tell us about Sylva, a Proxmox-like manager for jails, Bhyve, and other things in FreeBSD that I'd say is showcasing FreeBSD. He's an absolute delight to work with, and that's exciting. The folks at Karios will join, Ian and Chuck. And then we'll have some little talks from individuals about how they use Bhyve in production. I want this to be interactive. I want this to be a soft thing. Jan will probably share a few words on Bhyve in jails and some of your work. Patrick is very interested in TrueNAS Core and its future and its alternatives and its perhaps new form in ZVault IO, so I hope you can stick around for that.
10 minutes will be enough.
Perfect. And everyone wants clustering, but doesn't always have a firm definition of it. Patrick, you'll have a discussion on, was it CPUID FS in the next few days? And Dave, you've certainly moved mountains on your various clusters. And we will touch on those as appropriate as the day unfolds. That's what I have to say. Any questions here and now? Restrooms are either out and about past the registration or down the hall here. Bless you. Welcome. So thank you so much for coming. Come on, set up, Hans. We have exceeded all expectations on the registration. Double P Philip is very impressed. I hope we have food for everyone, but if not, we'll figure something out. Above all, thank you. Seriously, it's just been so good to meet with so many diverse folks from around the world. And after lockdown, we all kind of learned, we learned that, so you're good. Let me give you this microphone. We learned that we're down to time zones, languages and time zones. Otherwise, it's like, hey, let's just jump on a call with, be it Melbourne, be it Belarus, be it Berlin, all the time. So seriously, thank you. Let me rig you up. This is recording. We'll just kind of put it in a pocket or something. And do introduce yourself. You've worked for some pretty nifty organizations. And
thanks.
The floor is yours.
Can you all hear me? My name is Hans Rosenfeld. I'm a illumos developer for the most part, living in Dresden, Germany. And been working pretty much exclusively on illumos since 2012. I do a bit of NetBSD for fun, mostly on the digital VEX systems. And
That sucks.
I'm sorry, what?
Nothing sucks like a Mac.
Oh, that's true. Yeah, so in the past, during my career working on illumos, I worked for Nexenta, mostly on storage drivers. I worked for Giant, where I was a part of the team that imported Bhyve into illumos. The actual port was done by a company called Pluribus, I believe, to open Solaris. So it was quite old, and then we pulled in all the many improvements that FreeBSD did in the meantime and kept maintaining and improving it in illumos for this models and Triton cloud environment that Giant built. Since 2020, I tried to get by as an engineering contractor, and yeah, that works sometimes not quite as well. So today I'm going to talk about CPUID control for Bhyve, which is one of the features that we're needing for live migrations, one of many features that we will need. Structured my talk like this. I'll give a bit of technical background, explain how the CPUID emulation works in Bhyve right now, then describe what is there already, the kernel bits that were necessary, the user space bits to use the kernel bits, and from there we're getting to what I'm actually want to do next is what I sent as a proposal to the FreeBSD Foundation, is make CPUID control actually usable, but we'll get to that. The technical background, I don't know how many of you actually know what CPUID is or isn't. So let's start there. Back in the old days, it wasn't always easy for an operating system or a hypervisor even to know what it's running on. Usually you want to know what CPU vendor is it, what family, what model, what stepping, what features does it have, what instruction set does it support, what's the topology, what do the caches look like. And also, most recently, what are the errata that I have to expect to run into? What are the vulnerabilities in CPUs, which is apparently a thing recently, and of course, the mitigations for these vulnerabilities. And up to about 1993, talking about x86, the other architectures had this much earlier, you would use some handcrafted assembly code to test for presence of certain instructions and obscure side effects, and then make a deduction what CPU and model and family and vendor you're actually on. And you would have to have embedded, hard-coded knowledge about what features these CPUs have and what errata they have and how to handle that stuff. And in 1993, Intel introduced the CPU adaptation to the x86 architecture with the original Intel Pentium. And you have one instruction, and you can ask the CPU for all kinds of stuff. And this data is structured into what they call leaves, and some leaves have optional indices where you get even more information. And the structuring has allowed this to be extended and be used by multiple vendors, although the information does diverge a bit from vendor to vendor. The CPUID leaf you're interested in is passed in EAX register, ECX if you need an index, and it uses EAX, EBX, EDX, and ECX to return the information. That means on 64-bit systems, the upper 32 bits of the registers kept clear. And this is what it looks like in assembly to get the most basic CPUID leaf, which is 0, and uses no indices. And this is basically the result that I'm getting on my laptop for that. It tells me how far can I take the CPUID stuff. So the maximum leaf is D, and then it tells me that I'm running on a genuine Intel system, which apparently is a good thing. Other vendors report other stuff. And this brings us to the next step. We need to emulate CPUID in Bhyve. Pretty much most stuff that the VM might ask for can be passed through from the host CPU because there's really nothing secret about it. We want to mask some features. We definitely mask out VMX and SVM. We mask out speed step thermal monitoring, all kinds of stuff which the virtual CPU has no business dealing with. The virtual machine doesn't need to care. And other things we have to modify in the CPUID information as we get it from the hardware, which is stuff about the SMP topology as the virtual topology of the virtual machine has nothing to do with the real one. Same for cache topology, probably, and also things like hypervisor identification and hypervisor features. I know that KVM and Hyper-V are making a lot of use of that. Bhyve, I believe, only supports the basic CPUID leaf for hypervisors, which is, funnily enough, in a reserved area that no CPU will ever use. And that leads us to the missing features that we have issues with when we want to do live migration. The biggest problem is, what if the receiving VM host uses a different CPU, even a slightly different CPU? It may be lacking a feature that the VM has come to expect. It may be suffering from a vulnerability that the sending host didn't have. So the VM doesn't expect to suddenly run on a system where it has to do something about a vulnerability. And even worse, that's where I get the most complaints about, is you make a change in the CPU model brand string topology, you may lose your proprietary software license because it thinks you've moved it to a different system. And this is actually a problem even if you're migrating your VM offline, shutting it down and booting it up on another host. Another thing that's been asked for is to modify the hypervisor signature so that we can identify as KVM or Hyper-V or whatever we want, because also there are some softwares making assumptions if it's not running on a physical hardware, it's checking the hypervisor signature, and if it's not KVM, it just refuses to work. Other stuff is feature masking architectural downgrade. That's probably going in the same direction as the NUMA stuff in Bhyve. It's mostly for software development, OS development in particular. Okay, so there is a bit of this stuff that we already have. The kernel bits have been implemented by Oxide for their Propolis hypervisor. Propolis uses the Bhyve kernel parts on illumos, but they have their completely own user space code written in Rust. And they implemented live migration a couple years ago already. And for that, they added CPUID control. So basically, you have an I/O control where you can configure the CPUID data for a vCPU, and it replaces the entire CPUID emulation for that vCPU. You can actually do different stuff for different vCPUs, but that's, apart from a few small things where I'm getting to in a minute, is probably just screwing stuff up. So you usually need to configure every vCPU of a VM if you want to change the CPUID information. It does not do any sanity or safety checks of the data that you send there. If you want to screw it up, you can. It's very easy. And then, of course, when you do that, you must make sure that you match the VM configuration, especially when it comes to the number of CPUs, SMP topology, and things like that. This was relatively easy to port to FreeBSD and is out for review. Has been out for review since July, I believe. And now we're getting to the user space part because the kernel part alone isn't really all that useful. I did that in July and put it out for review. And what it does is it adds a wrapper to the I/O control interface to the libvmm API. It adds options to Bhyve for the Bhyve configuration file to set CPUID information, global CPUID information, and per vCPU information, and then constructs a set of CPUID information for each vCPU out of the stuff that you give it. And of course, I needed I needed a way to check that the kernel actually got what I configured, so I added a command to Bhyve control. Yeah, but it's not exactly user-friendly. It's really just access to the raw data that the CPU gets. And this is what the configuration actually looks like. If you think that is terrible, this is not even 10% of it. It's like a whole lot more. What you can see here is a couple of global CPUID values that are used for all vCPUs. And since the VM I did this on has just two vCPUs, I have an override for vCPU 1, where, for instance, I'm setting the APIC ID to 1 so that the system knows what it's doing. Yes? Yeah.
So if leaf is not specified for a specific vCPU, does it see the default one? And if so, can you hide one just on one vCPU?
I'm getting to that in a minute.
Okay.
Because that's exactly that. It's not really usable. Well, you can use it, but it's terrible. The way I did this for the test VM is that I ran the VM without any changes, ran the CPUID utility, piped that through an awk script that created the options, and then started filling with bits after consulting the documentation. What would be much more useful is that if I don't have to specify the APIC ID, for instance, if the system would do that, I give it global options and the stuff that need to be at certain values, it will just do that automatically. One way I think we can do that is that if we pass CPUID information into Bhyve, it will pass them again through the emulation code. Where does these changes? That's currently not done. That's not something that Oxide implemented in the kernel part. Probably they didn't need that. They have something similar for CPUID stuff that needs to change when certain MSRs are written, but that's something else. Or, as you asked for, you can specify data where you just want to override a single register that is returned, or even just turn on or turn off bits. So what I'm doing here is I'm overriding in CPUID leave 1 the bit that says the CPU has a processor serial number. Or here I'm just turning off, I wonder what it is. Anyway, some feature that isn't strictly necessary. And over there, the next line, I'm setting the actual processor serial number that I turned on. The processor serial number was a feature of the Pentium 3 architecture, so that's really old. No CPU has supported it since then. But with that, you can have it on a VM on a modern system. I don't think it's particularly useful, but it can be done. Going from there, if you want to override a hypervisor identification, it would be nice if you could do it just like that, or something like that. And even if you want to say, I just want to specify a particular real CPU, if we add a CPUID database to Bhyve, you can specify the brand string and it will fill in the rest, or you specify an x86 architecture level, or you downgrade it to an Intel 486 if you like.
If you specify a concrete CPU like the i7 there, would that also control the number of cores you have?
It could be. It's not really there yet. This isn't implemented. But I guess the number of cores that you're configuring could be independent of that. So you could have a 32-core i7 from the first generation or something. Or you could have a 32-core, well, probably not a 486, but the original Pentium P5 if you want, for whichever reason. Probably OS testing. I mean, NetBSD is still supporting the systems very well. Yes, please?
Is this specific to x86?
Yes, this is all specific to x86. I mean, other architectures, I guess ARM64 has similar mechanism and probably not as much problems with that because it's a much younger architecture. But this is really all x86 only. Yeah, so this is this on the slide before that is what I have proposed to the FreeBSD Foundation, that we make this useful. Going from there, it's the second part that Michael showed. The problem that we have when it comes to FreeBSD and illumos and diverging code bases. So illumos imported a really old version of Bhyve back in 2017 and then pulled in all the changes from FreeBSD and then has been working on that. Some of the stuff that illumos did has made it back to FreeBSD, but I believe since 2020, not much has happened there. Illumos is continually pulling from FreeBSD, but most recently they've started to leave out kernel bits because the systems have diverged too much, and a lot of the kernel changes they weren't interested in, like GPU pass-through stuff. And of course, the code was refactored and reorganized everywhere. So that is really a pain in the neck. This is an awful lot of work to figure that stuff out. We really want to basically go through the commit list of both operating systems and walk them one by one. And each one that we port in one direction or the other, well, probably just port to FreeBSD needs to be tested individually, as we don't want to break things. I did go through the list of the illumos commits yesterday and looked at some stuff that I think is interesting if you want live migration in FreeBSD's Bhyve. The Bhyve test suite was not necessary for that, but it's nice to have. That started out at Giant, and Oxide has been continually improving that. Oxide has added dirty page tracking, which I think we really want. They have made changes so that the kernel device state for the devices that the kernel side emulates directly, like the APIC and other low-level stuff that the architecture needs. That is exposed completely to user space, so you can save it and send it on over. Same with vCPU states. CPUID control we were talking about, and they also added VM pause resume, which is not exactly the same as suspend resume, but definitely needed for full live migration. And there is more. There's about 5 years worth of changes, although the stuff that's relevant for live migration, I think, made it into illumos in 2023 already. Some of that, like the CPUID controls from 22, so it's a bit older than that. So I think at this point I can conclude my presentation. If you have any more questions or any suggestions, then please speak up.
Between, yeah, please. Dave, you might have answers on this. What does the diversity of ARM64 look like if it were to be a CPU type topology and profile? Is it far simpler than Intel?
I don't know, but there's definitely less of them. But I don't know. I'll look. Yeah.
Appreciate it.
One more question? If you have any questions?
Yes.
So this was very interesting. Thank you very much. Which bit of it did you enjoy the most, and why? and is there therapy available for this? Yeah.
Is there what?
Therapy, yeah. It's a joke. Yeah. Which bit did you like the most and why?
Well, first of all, I don't think there's a therapy for that. And I just enjoy fiddling with bits. And so, yeah, just porting this stuff is usually a bit of nasty work because you have to work out all the difference in the code. But actually getting in there and changing stuff at such a low level and most likely break everything that's running in a VM in the process and then try to figure out how to make it actually work is something that I think is a great fun.
I'm curious about, I don't know anything about the illumos community. I'd be very interested if you could just maybe sketch, you say there's a lot of stuff happening around its like who's active? Like, is it mostly Oxide, or are there a lot of companies and individuals involved?
Well,
I'm just
certainly not a lot of companies. So in the past there were a handful, and that I believe that shrunk a bit. So what once was Giant is now owned by a company called Edgecast. They're still doing Triton and the Triton Cloud, still developing SmartOS. Oxide is a pretty big part by now. Then I think all the storage vendors have pulled out. So they were bought up. I was contracting for them for a while, and then they at some point said they're just supporting existing customers and not doing any new developments. There's a couple companies in Europe that use it, and I'm right now at this moment contracting for one that wants Word.io SCSI on illumos for SCSI pass-through. And the community in itself is small, and anyone can contribute. You don't have to be a member, as you do in most BSD communities. And there's a core team which I'm on, which basically gets to decide what goes in and what not. But this is following a formalized process, so there's really no reason, okay, we don't like you or we don't like your change. If it passes code review, then and you can provide testing, then it usually goes in. So it's not much room for interpersonal conflicts there, I hope.
Thanks.
So for those who have watched the calls, there is Andrew H. and Mark G.
There was a point that I think Andrew's attended more calls than I have, which is impressive. They are both with Promenic in Illinois, an ISP on-premises that catered to a lot of ex-IBM Domino and Friends applications, all on OmniOS, all on super early Bhyve before it was even ready on illumos. And they came to the calls with great questions, great energy, great everything. And they're just an invaluable part of that community. And so thank you, Promenic. If you're looking for hosting, I'll gladly push them. Diversity is very, very important. And just to, I touched on very briefly, Meet BSD, there was VBSDcon with VeriSign, a completely dual stack company with Linux and FreeBSD to keep .com running. Diversity is really, really important. Yes.
Well, Michael, this might be a question for you, but how do you two see the reconciliation of the changes in illumos and FreeBSD? I guess the calls are the start for it, but is there any suggestion how to start? I suppose FreeBSD is upstream in this case.
Well, my take on it is just something that needs to be done, that should be done. It should be beneficial to both projects. I mean, wouldn't it be amazing if we could do live migration between an illumos host and a FreeBSD host, for instance? I don't think there's a reason why that shouldn't work.
You heard it here.
But I'm not sure that's actually a useful feature, but it would be awesome if it worked. That being said, it's going to be an awful lot of work, and it's going to be tedious and not very interesting. You really just have to go, okay, what was done on one side on the project, what was done on the other, and how did it diverge? And if I go back like 5 years and take the changes from illumos and starting there, I have to adapt them to current Bhyve and not to the state of Bhyve and FreeBSD 5 years ago. So I have to adapt all of that to the things that have changed in FreeBSD right now and have to test them. And this is what makes it tedious and a lot of work, especially the testing requirements. Well, how to get it started? Well, just do it. And ideally, someone to fund it. That would be awesome.
And how many subject matter experts do we have on a mix of illumos and FreeBSD? I can count one so far. Thank you, because Hans, like, wow, we are blessed to have you doing this, because generally people come from whatever camp, from their first days in college on a Unix system and just stayed with one or two OSs. But the fact that you crossed the aisle, as I say, is invaluable, and I appreciate that. A similar discussion is taking place with OpenZFS. Illumos is still on their original ZFS, and they cherry pick from OpenZFS, and people want those latest and greatest features. They want, you name it, XML output, all sorts of things. So I think Illumos is very much a friend of the BSDs. You can look at that as not Linux, but hey, that's, you know, look at it from whatever perspective you please, but I think that diversity is critical. Any other questions for Hans, be it on Bhyve, Illumos, zones, anything else? And there's a point in many of the calls when Hans and Andrew and Mark start discussing crossbow networking. And they have warm towels and cookies and a mint on your pillow. They have so many nice things that came out of Sun that such attention to detail went into, and are performant and consistent, and just put ADM on on the end of any function you can think about maintaining in the OS. So I think we all have a lot to learn from Illumos, yet you're still in GCC, is that true?
Yes.
Okay, well, someday some Clang LLVM, and I know there are projects for ARM64 out there and RISC-V, but they're definitely not our enemies, that's for sure, and it's been a delight to work with everyone like Hans. So,
thank you.
And if there are any other questions, great, but let's move on.
Let's move on.
Thank you.
Thank you very much.
Thank you. It'll take a moment to wire up Alexi. Maybe we take a quick break. I don't know if they have fancy coffee out in front, but thank you, thank you, thank you.
Okay, hello. Test. Test again. Test. Yep.
Give them a moment. For me? That's a good question. Hans, do you still have the microphone that says speak fuzzy? Oh. Oh. Sorry. I'm glad you didn't run to the restroom. Do that. Next speaker. I suppose I'll put this on.
Next all over.
Me already. You've got a lifetime supply of me. Jan has the mic. And Alexei, once we start, go ahead and introduce yourself and then just let her rip.
So hello. I like how to introduce myself exactly. I guess I started. Oh wow. This is tough.
No pressure.
Yes. So I'm new to all of this Bhyve stuff. I started doing all of this just recently, and I found a lot of things. And I'm now just experimenting a lot with pass-through, with firmware, PCI stuff. It's fun. So yeah. Do we move on to the GP pass-through update? Let's go. Chapter 1, the reset bug. You can see this is the domestic output of a Linux virtual machine of the AMD GPU driver, absolutely failing to load. If you have this mess in the MESG, that's probably the reset bug. Code 43 in the Windows virtual machine after restarting a VM. It worked before, you restart, now doesn't. Probably the reset bug. IVHD errors can be rarely seen with faulty PCIe hardware, and code 43 can be caused by other bugs, such as faulty drivers and rebar, which will be discussed later. Why does this happen? PCI devices are only meant to be powered on once. The process of passing them to a VM allows you to initialize the device without a power cycle, which results in improper configuration of the state machine. That's pretty much it. The state machine holds a bunch of registers with a bunch of values. That's what we call the PCI config space. And here are the registers over on the right, and a diff between ones of a GPU without the reset bug and with the reset bug. So is there a way to fix this? Kind of. The classic solutions. Radio and reset bug fix. This works only for Windows VMs. It causes spontaneous Bhyve board traps. Very limited spectrum of devices supported. Only AMD GPUs. Requires a clean VM shutdown for proper GPU deinitialization. So if you Control-C out of Bhyve, you need to reboot your entire host. And we also have vendor reset. This is only for Linux VM hosts. As DIY as it gets, you need to compile the kernel module. A very limited spectrum of devices supported. Only AMD GPUs, and not even all of them. Only Polaris 10 to Navi 14 GPUs. That means RX 470 to RX 5000 series GPUs. Or rebooting the entire host when the reset bug occurs. Yeah, that is not much of a solution. And this is where we're going. The PCI conf command, read and write. we're going to be taking save states. I have made a script that allows you to take a save state of a PCI device of the entire config space. Similar to how you take a save state in a game on an emulator. Yeah. But we have some issues. We can save the current state machine config space in a file and load it later. But this is pretty new. No documentation except for a help message that I made. The process is not very understood yet because I just started experimenting with it. And it's very messy. It can break stuff. Some devices completely ignore the writes. I don't know why. For example, the 0x6C register of the GPU, this is, let me remember the name. This an IO function, I believe, register of the GPU. All registers above 0x20 or 40 are vendor implemented functions that we don't know anything about. They're different on every single device. And everything above 0xFF are extended vendor registers, which are even more cursed. Do not write to them unless you know exactly what you're doing, because you might actually damage hardware. So, yep, we're reading, it's this value, we're writing a different value to it. We're getting a success code, but it's still the old value. Some devices like to completely zero out their config space or fill it with ones as soon as the reset bug happens. I don't know why. After that, they ignore the writes again. But does this actually help fight against the reset bug, my script? Yes. It helps. Only on Linux guests. I did not manage to make it work on Windows. For Linux and FreeBSD guests, you take a save of the config space of your GPU or some other device that suffers from the reset bug before you even start the VM. And then after it shuts down, you load the config space on each shutdown or restart. Sometimes I need to do a devctl reset on the PCI device, and it's bridges, as you can see here on the screenshot. I did a, well, screen photo. I need to do a devctl reset on the PCI device of the GPU and its bridge devices that it creates. There's still a lot of work to be done. I don't know when to do a devctl reset, but sometimes doing it breaks things, sometimes doing it helps things. Yeah. There's still a lot of things to be discovered. Anyways, chapter 2, EZK2, the firmware. We got a new logo and a new version. I made a patch. It works in Bhyve perfectly fine. And we have this very awesome logo that Michael Dexter suggested to me. So, is it in the repositories yet? No. It's been like that since spring, and it's still not merged. The bug report is just sitting there. People comment, and then it gets forgotten again. Chapter 3, Intel Arc GPU pass-through. Don't worry about how janky this looks, because this has been taken by dumping the PCI bar with PCI-conf-d and reading it with GIMP. This was just an experiment of mine by trying to take a screenshot with from the VRAM. Yes, I succeeded. I took a screenshot of the terminal with wrong colors, but still from directly the VRAM of the GPU. And yes, on the screen, on the actual display output, it looks correct. So, Bhyve forces all Intel GPUs to use GVTD for pass-through. It's the old technology that Intel used for GPU graphics virtualization. Intel has abandoned it, starting from Tiger Lake CPUs and that time, around 11th gen. So Rocket Lake still has GTD, Tiger Lake not supported anymore. And 12th gen, there's SR-IOV, which is a whole other thing. I do not want to even remotely go near SR-IOV. How do you pass through the new GPUs? And I did not finish my presentation. I'm going to have to talk about this right now. We do a patch for Bhyve to just check if the GPU is on a list of all the old GPUs that support GTD. If it's not on a list, then we use the normal pass-through, and it works. Demos and discussion. Let's do a couple of demos, shall we? Okay, I can use OBS to share my screen. Yep. This is a machine with GPU pass-through right now. And it's gone because oh, never mind. I don't know what's happening right now. Why is it typing my phone? Here we go. I don't know why is it so slow right now. Let's probably reset this whole thing and try it again, because something happened. Message into Alex at my FreeBSD machine, and just kill Bhyve. Okay. Okay. I have a terminal over here, actually. I should just use this. Let's restart the whole VM. Okay. Yep. Yep. We're fine. I need to make this smaller. Here we go. Console TTY S0. Let's see, will we get the reset bug? It would be actually good if we get it, because then I could demonstrate the script. But it's pretty rare in Linux VMs for some reason. Oh, no, we don't. Look at OBS. Here we go. It's passing through fine. Oh, I forgot. Full screen, here we go. This is an RX 7600 GPU. It's yeah, it's an entry-level regular Radeon RX GPU. One of the previous generation ones. It works fine in pass-through. Sometimes. Sometimes it reset bugs and I do a state restore. But I'm still experimenting on that. Let's show the Intel Arc stuff.
And while you do that, point of order, these reset bugs impact every hypervisor out there, such that every forum on KVM is packed with...
It's just the quirk of PCIe.
Paint. It was never meant to do this, but people are pushing it to do this, and here we are. So
Sudo reboot. Let me reboot completely and plug in the Intel Arc GPU instead. Okay, will we get display output? The PC is booting right now. It takes some time. Oh, here we go. We got display.
Yeah, go ahead and full screen that.
Okay, yep. I will still have to SSH in and do myself over SSH. But yep, here is my PC. And let's now do pass-through of Intel Arc. One of the quirks of Intel Arc is that you don't need a VBIOS. You just add it to BPT-devs, and it sort of works. So let me do BPT-devs. I have a script that does this for me, that does all this stuff. Actually, where is it? PCIconf LV. Oh, PCIconf. Intel Corporation, here we go. The bridges and the GPU of audio. It's 4500 and 4600. Cool, we do export BPT-devs 200, that's my USB, 4500, 4600, bind.sh. Okay, now let's do Bhyve, VMs, I'm gonna scale up the font. PT test.bhyve. Let's change this to remove the VBIOS. Because don't need it, and change this to 4500, 4600. And yeah, let's leave it as 7071.
So you don't have to synchronize the hardware addresses with the virtual ones?
Yeah.
Cool.
Now let's do VMs. This as a Bhyve. Before doing that, let me SSH here. Sudo cu-l. So I don't forget to switch serial. I forgot to take a state of the GPU. Let's do it right now while it boots, if I can. There's still no display output. Oh yeah, it blanks the whole screen while it passes through until, oh, here we go. Too late, it already passed through in driver load. So here we go, that's Intel Arc and pass through. Let's do LSPCI and open a web browser or something to see if there is graphic acceleration.
Go ahead and full screen that if you can.
Oh yeah, forgot.
No worries. Guessing acceleration of some cool kind.
I forgot, where do I check acceleration in Firefox? Let's just open YouTube and see if it shows that it's accelerated.
Kitty. And mind you, we're seeing this over Zoom.
Why do I have to watch 2 unskippable advertisements just to watch a video? YouTube.
How relaxing.
Well, this is either the CPU doing good work, either the GPU, but I can see it's VP09. Yeah, I think it's doing GPU decoding. Yeah. Let's look on top and see if CPU is suffering. No, doesn't seem like it. It's actually the GPU doing everything. Firefox is only using 33% of the CPU. If it was actually decoding on the CPU, it would be using much more.
There's also Intel GPU top to see the processes that are
Okay, now about the patches to Bhyve.
So an audience member said there's an Intel GPU top that might show you more information. I don't know if that's in your local packages for that OS.
No, it's, what's the package name?
Intel colon GPU colon top.
Intel-GPU-top, I believe,
Intel-GPU-top, let me see, Intel
or some variation on that.
top. Oh, I haven't signed into Kagi here.
It looks like Jan came to the rescue. Thank you. Maybe Intel GPU Tools includes it.
Oh yeah, it could be.
I don't know if you still have a chat. Thank you for that. I'll write that down.
And I think for AMD devices, it's called Radeon Top.
Yep.
So Radeon top on AMD, cool.
I don't know how it's pronounced.
We've got your SSH.
Oh, wait. Here we go, I got it. Over here, I got Intel GPU overlay.
Ah.
It says GPU frequency not found in debug. I don't know. Yeah, let's move on to the patches instead.
Well, cool. That's
So,
tangible.
user has been Bhyve, AMD64, it's all here. We have only added PCI GTD devices. Here's my only addition here. It's this. It's a list of all devices that support GTD, well, device IDs. And then we have the C file. I added this for checking. Yep, it's just a for loop that checks if the device is in the list. Yeah.
Hans, have you had a chance to look at that? Simple? Not yet. This came up very recently, but hopefully that can make it itself into a patch and get Corvin's review of that.
This might need to be 0x02.
Cool.
But okay.
Do you have other things to demo?
I don't know. Let's take a state of the GPU and do something funny with it, like write wrong variables and see what happens to the VM. Just have fun with it. Hey dev, states. I have some states here. Here's a like, cold boot. Yep. Actually, yeah, this would be a good demo of my script. For states, it saves the state in a directory with a bunch of files for the PCI stuff. And they're just a CSV of address and value. You can pipe it into less. Here we go. Just an address value CSV. So let me go to state.sh save. GPU broken. Just break it 4500. Let's go to GPU broken and just edit this. Oops. Let's just change some variables to something wrong here and see what happens to the VM if we load one. Yep. We're gonna break the GPU.
Well, be nice to your hardware.
Yep, it's not gonna explode anything. Actually, I should not change anything above FF. That's the thing you should not do, because it has like the power for the GPU and fan speeds, all of that. Yep, this is probably enough. 4, whereas for here go, I should change this something like this. Not let's state.sh load GPU broken 4500. Okay, now let's see what happens to the virtual machine. It's already frozen. It just instantly froze. Cool. Will we get the reset bug? This will probably, oh, yep. This will most likely reset bug the virtual machine because, oh, yep. Did you see all the errors in the mask? TTYS0. This might be a good demo of the reset bug because that's pretty much what reset bug does. Just wrong variables over here. They get left after the VM. Like the driver doesn't clear the variables back to their old state. Let's see. Nope, it didn't reset bug. Cool.
And to state the obvious, vendors are notoriously proprietary about all that information, such that much of his work and any other one working on GPU pass-through is just riding blind and hoping for the best. And
yeah, all of the variables above like 40 or just, yeah, all variables above 40 hex are just unknown. You don't know what they are.
And that's with the Intel Arc?
Yep, that's, with Intel Arc, you might be able to find them in the official like GPU programming documentation.
Exactly, I'd hope they'd be slightly more open.
But with AMD, no. With AMD, they don't have any documentation whatsoever for them. I found some reverse engineerings of them, but it's only for the above FF registers, and it was only a couple of them for power and fan speeds. So yeah, do we move on to the next person?
As the next presenter?
Yep.
So, there are about 30 people here. How can we help you?
What?
How can we help you?
Somebody there said an NVIDIA GPU. Let me see. There's a Bhyve user in the room who would like NVIDIA Quadro RTX to work with GPU posture on Intel and may be willing to send one your way.
Are you still? Yes, you had that hardware, was it?
I have AMD. I have AMD hardware, but what did show? It was void Linux.
Run on up here. He'll hear you from here. So join me. Yep.
Okay.
Let's do this.
I don't know. I don't really like accepting like such valuable gifts like this.
So, what's your name?
My name is Sharda.
Hello.
I work for the Middlesex University. We are trying to have NVIDIA RTX 8000 GPU pass-through, and that, for some reason, is not working. It's on Intel platform. So it has the Intel CPUs and everything, and every time I try to pass the GPU, the system literally stays in the blank screen. It does nothing, goes nowhere. If you're interested, I might be able to ship one of them to you, assuming that you're going to return it once the work is done, if that is okay.
I'm in Belarus. You can ship it here. The postal services here, yeah, they do ship from Pakistan and from...
No, from UK.
From
Middlesex, UK?
From where?
United Kingdom?
United Kingdom. Oh yeah, they do ship from there.
Are those available for purchase locally?
I don't think so. Let me see.
Okay, and we can have this conversation separately, but, and what's your use case at the university?
We use the GPU-based systems for various different research, computation work, genome detection, and things like that.
Are you using Bhyve?
We have migrated to Bhyve, like I have said, because VMware has done such a brilliant job. Well, I have been using Bhyve for many years, and I was trying to find an excuse, if I may say so, off the record, by the way. So whenever the opportunity came and we did a cost calculation, it was a no-brainer. So.
Well, let's discuss some hardware offline.
Yeah, definitely.
Yep.
What's been your, I think we were asking Hans earlier, like what was the easiest or hardest or most fun? What's been your greatest discovery on Bhyve? Beyond cost.
Well, no, because I had been using Bhyve for many years for various different smaller projects and things like that. And one of the recent finds was the NVMe, definitely. It improved the performance in such a brilliant scope, which was fun. And if I may share one of my sadness is that when VMware announced that they're going to get merged with Broadcom, I was hoping, because I'm not a developer, I'm just basic sysadmin. So I was hoping that the Bhyve community will actually come up with something that would give us the option to replace VMware in exactly the same way we need. Say, for example, things that we do look for. In case something goes wrong, we have to go through audit, memory audit, and things like that. Bhyve, to my knowledge, I might be mistaken, please correct me. Bhyve still doesn't allow me to save the entire virtual machine state along with its memory, like the way VMware used to do. That might be something to work on. Or I do not have I have racks of systems and they are all silos because I do not have a centralized management, which is a sadness. And I suspect, or I assumed, that somebody would come forward because these are good options to get into the market in whichever way you want to do it, even if it is like just technical support for a silly money or whatever. But you had, or the Bhyve community had a very good opportunity to take over the void that was created by VMware. Sadly, that didn't happen, which is a sadness for me.
Do stay for the 1430 presentation on Sylva. I don't know if you've been tracking its development.
No, I have not, but
okay,
I'm
well,
going
come to the right place.
Well, I'll try to, but I have signed up for another tutorial.
Oh, no worries at all. Okay.
As long as it's recorded, I'm happy to watch it at some point.
Absolutely. Well, cool. Thank you so much.
Thank you so much.
Other questions for Alexei? We're actually back on schedule in very progressive ways. Mecca, come on up. This is great. I want to go full Oprah here. And that was the RTX 8000.
Yep.
Yes, sir. Hello.
Sit here if you're brave enough. Right. I was wondering if you looked into or have some opinions about GPU sharing. Now, I read that KVM has GPU sharing between the host and the virtual machine, and Corwin once showed me when I was researching TPM, he showed me how the QEMU does the software TPM, and it took me 15 minutes to realize I'm actually looking at the C code. So I know it's not the most understandable code in the world, but have you considered GPU sharing and avoiding the resets altogether? I mean, reset bugs.
I have not looked into GPU sharing at all, but I believe on Intel I know it's using SRIOV now, which I believe needs a full-on GPU driver on the host to be loaded, and then for it to load a compute kernel into the GPU. That is usually what Vulkan does for like graphics. It loads a compute kernel that somehow shares the GPU into the VM that you need to first make. And after that, I don't really know else much like what is happening. On AMD, I have no idea, except that it somehow utilizes OpenGL to, like Virtio and OpenGL or something, to share the GPU with looks like using the Virtio driver. It doesn't actually use the native GPU driver on QEMU, but the Virtio one.
Okay, thank you.
Well, Alexei, do you have anything else to share?
I don't know.
Well, I, for one, would like to thank Alexei for his very first presentation. Thank you.
Well, this has been stressful.
You have immense support from all of us. Yeah. Okay, well, maybe we take a little break. I'll connect with Zaman. What time's lunch?
Okay. I really want to take a
Coffee
look at
served
this
now. Perfect.
presentation.
Okay, well, thank you, Alexei. It's been fantastic.
Yep. Yeah.
Let her rip. So I'll do a pre-intro. We have Boyan jumping in to talk about his NUMA work.
So I just want to take up a couple of minutes of your time, since, as Michael pointed out today, Bhyve recently gained support for emulating NUMA inside virtual machines. So I would just like to kind of, first and foremost point you that this option exists, you can use it, and kind of lay out a couple of use cases that might be of interest. So this originated from my virtual memory work, where if you're implementing anything if you're basically adding any new mechanisms, patching things, you have to make sure that the thing you're developing works on NUMA machines. So, and if it doesn't, that usually means that you have you oftentimes run into a lockup when dealing with memory shortages and stuff like that. So these patches have been in the tree for a couple of months now. They've been in review for several months, but yeah, that's to be expected. And yeah, so first and foremost, I think the most common use case is going to be, okay, I need to test something NUMA related. I don't have a NUMA machine. Those are expensive. So you pop this. And so the way this option was envisioned, it allows you to specify, which is the, it's visible. So it's the -n option. So the way this works is you can associate a given set of CPUs with a specific emulated domain. And you can give it an arbitrary memory size. Of course, as much as your hardware permits anyway. And you can mix and match, have as a maximum of 8 NUMA domains. And the other use case, the cool thing is that you can also control the way that a specific emulated domain's memory is allocated. So for instance, let's say that you have an actual NUMA machine on the host, and you want to pin a certain virtual machine to a certain host domain. You currently can do that, but only for the CPUs, right? Memory is being allocated in an interleaved fashion, which means that it's kind of spread out across all domains of the host. And this way, you can actually tell it to source memory for that specific VM only from a domain that you want to. So from a local domain, from all domains, you can control practically the way memory is allocated for that given VM. So skipping ahead, I think there's a couple of examples right at the very end. Yeah. Okay, so here are a couple of incantations. The first one being just a very simple rough use case of I want 2 NUMA domains with 4 GB each. Nothing too, exotic, I hope. You can assign any combination of CPUs you'd like to those machines. And an important caveat here, it only supports running in UEFI mode. So Bhyve load, usually the one that's now considered to be deprecated, it kind of preloads and pre-creates the Bhyve loader, pre-creates all the memory configurations and the memory slices for the virtual machine, and editing those after they've been created is just too complicated. So yeah, sorry. And the other thing, the second use case I was talking about. So this size here basically says that give me a virtual machine with a single emulated NUMA domain, but I want to only allocate only want to allocate memory from the domain number 0 on the host, which if you're using any sort of, I guess, high impact traffic, you want to minimize the bandwidth. You want to minimize the bandwidth traffic across NUMA domains, right? So this way you can effectively pin this virtual machine to domain 0 on the host. So you avoid this cross-domain traffic. And that's about it. I mean, I hope that somebody will find this useful. Mostly for developer workloads right now, but yeah, that's it. Any questions? Great.
Thank you. That was awesome. So, we have a little bit, about 40 minutes until lunch. Does anyone have stories to tell? We will have Joran later, but shaking things up. Cool, perfect. You're so well equipped. Katya, would you like to tell us about Bhyve at your organization? Come on up. This whole call for participation thing, come on, we can condense it down to on the fly. And yeah, introduce yourself as you see fit. You can take this.
Thank you so much.
Welcome.
Hi, so I'm Katya. I work at Bell Tower. It's a New York-based company, and the company has a CEO, Daniel J. Bell. So Daniel has created the Zelta replication suite. So I don't know if you heard about Zelta before. You did? Okay. Well,
Zelta's awesome.
it is awesome. I had to slip a word in about Zelta. So, sorry, so you wanted to know about...
How you use Bhyve at Beltec.
So, at Beltec, we use VMBI in order to, for deployment, for configuration, and we associate it with Salt, Salt stock. Oh, sorry. So basically, at Beltec, we have a few some thousands, sorry, of servers and hundreds of instances, jails and VMs, and for our clients, so basically we blend hybrid infrastructure, and we use also on-prem. Actually, we adapt. Sorry, we adapt
take your time.
The system to their needs to make sure that it's secure, compliant, resilient. So let me tell you more. Yeah, so the reason why we use Bhyve is for control and security, of course. Always verify, never trust, and that's the approach that gives us a tight security posture. We also use ZFS integration. We use ZFS snapshots and our tool Zelta. So for ZFS and Zelta, it's set on all of our instances and VMs. And of course, we also help clients save costs thanks to Bhyve. So our clients are mostly fintech and healthcare providers, and they don't want VMware license bloats or vendor lock-in. So we combine FreeBSD, Bhyve, and they let us deliver a private cloud that's lean, that's transparent, that's secure. So, yeah.
What role do you play?
So I'm an administrator. I give love to the server. I patch them. I also help deploy them, allocate resource. We monitor them as well with Zabbix. So that's also a big part of my job, to find out how to monitor the most accurately without too much noise, and then we can anticipate a lot of possible issues. So we also, in my job, I get to work with Zelta, and that's something that I can say guarantees 100% availability because of the way we set it up, and so about my job, what else do I do in a workday? Let's say I come, I check for alerts, I check CV news. For my maintenance, I'm sorry, I'm a bit
Don't be sorry, you're doing great.
improvisation. And ZFS is our friend. We work, we breathe it, and okay. That's,
Show of hands, who has heard of Zelta? Okay, we have 4 hands here. Could you tell us about Zelta? And if you don't, I will, because I'm very, very happy with Zelta. And to quote Rod Grimes, co-founder of FreeBSD, it's the best backup tool he's used in 40 years. Go ahead. Oh, and I'll bring up the site while you do that. So yeah, tell us about Zelta.
So Zelta is our in-house.
Nope, not that one. Zelta Space. Thank you.
Exactly.
There wasn't a web page when I started, so I'm terrible at this.
So Zelta is our in-house replication suite, and it's a tool that works recursively on dataset trees, and it allows to support remote and local operations using SSH. So it's pretty flexible. I don't know if I should talk about it.
Tell us about the dependencies, because that's quite exciting, or complete lack thereof.
For dependencies, so we have a tool called Zelta Match that compares dependencies, and we have Zelta Backup, that's a robust ZFS dataset, tree that does replications with self-defaults. We have Zelta Sync, which replicates as quickly as possible, so there is minimal checks, and it's transferring the latest data only, which avoids slowing down. I'm sorry, just like...
No worries, you're doing great.
Nervous.
And I can elaborate on some of that if you like.
I would like that.
I think you'd like that. Well, thank you so much. You did fantastic. Thank you, Katja, for being put on the spot. You did fantastically well. So Zelta is written in awk, a classic Unix language. And there were some tiny issues getting it adjusted for, say, NetBSD and Solaris, such that you can push to a ZFS system on nearly anything without requiring some like daemon waiting at the other end to receive whatever you're sending. And Daniel's pragmatic. As a New Yorker, as he put it, you don't go partially in, you go all in. So it's very comprehensively done. It was developed in production and shared with the world. He liked the fact that Zelta is gold in Latvian, so he became a gold sponsor of this event. I appreciate that. That sheer lack of dependencies I consider invaluable. I use it strictly with zmatch and zpull, early commands before it got real fancy, but it collapses the range syntax that is a nightmare at the command line, just to say -I, big or little, and the full snapshots. You just aim the data sets at it, and it does the thing you want. And one final point is that Daniel expressed that if you're finding yourself having to force destruction of data sets and snapshots to catch up correctly, you're doing it wrong. You should never be destroying snapshots to achieve more backups. So check it out. There's the website. I'm delighted with it. He's been very interactive. He's worked with Rod for weeks on just dialing it into real world needs. Because developers by nature are either told what to do or scratch an itch, but then what happens out in the wild might be different and inconsistent with that. So thanks again, Katja. That was fantastic. Thank you, Daniel and co, and you for Zelta. A client of mine split their company after like 40 years in business and had to untangle
personal stuff of the owner with the new owners of the company. And I spent a week of my life in ZFS snapshots in Zelta, untangling, because you can always see exactly where you stand and move forward from there in little baby steps. And then verify with Zmatch that everything is actually copied over, and it will just tell you. I don't know, maybe I can jump into a system and give a demo, but I'm delighted with it. Can't say enough nice things. And it's free of charge under a nice license. Other stories as we work our way into lunch in about 30 minutes. Yes, sir. Alexander, do you want to come on up?
Yeah.
Let's, yeah, absolutely. Absolutely. Mike Larkin was a regular figure at these events in Tokyo, and I would absolutely welcome an update. Yeah. And go ahead and introduce yourself.
So my name is Alexander Blum, and I work for Genua. It's a company that creates firewalls and VPN appliances based on OpenBSD. And what we did in the previous 1 or 2 years is we were doing confidential computing. So confidential computing is a technology where the virtual machine doesn't trust the hypervisor. It has some, it uses some CPU features. Of course, they are all incompatible. There's AMD, which is a straightforward design. There's Intel, which tends to be compatible with their SGX that they had to make some confidential userland applications, and that makes it very complicated, and we didn't look into that. And then there's AMD, ARM, which is doing some works. I would say they're a bit behind, and we didn't look into that either. That's just what you're hearing there. And what we have done is we have implemented parts of that for AMD in OpenBSD hypervisor VMM, and also for the OpenBSD client, so that we can boot it on VMM, OpenBSD, and also on KVM. So KVM has more or less full support for all that features. And all the... Why are you laughing?
Because he was looking for Hyper-V, there was no mention on the schedule.
Hypervisor? Hypervisor. I'm looking for your talk. What day are you?
So, okay, so so there will be a talk from Hans-Jörg Höxter at Sunday, I think.
Sunday, okay.
But I can give you a brief overview what is there. So in AMD, the technology is called SEV, Secure Encrypted Memory. That's the basic step. So the idea is that every VM gets a key, and the memory is encrypted with that key, and the hypervisor can look into that memory, but it cannot make out what the guest is doing. That's the first step. Then you need ES, it's SEV-ES, like encrypted state, because the problem is when the VM gets stopped, then does a VM exit, then the hypervisor gets all the CPU state because it has to save it for resuming the VM. So at every interrupt or something, the VM gets stopped. And then to make that secure, you have to encrypt the data so that the hypervisor cannot, the CPU state. So if, for example, in the FPU, you have all your AES keys, and you don't want that the hypervisor sees that. So we have implemented that also. It's running on VMM as a host, and it's running in OpenBSD guest. What doesn't work yet is multiprocessor support. So it doesn't run on work on VMM anyway, but the guest on KVM cannot do it because it needs a different bring-up code for every CPU to get it up. So we haven't implemented that yet. The next step we are currently working on is SEV SNP, Secure Nested Paging, next AMD technology. And this is about the hypervisor can read your pages, and it can also write to your pages. The memory is encrypted, but you have a block size of 16 bytes, it's AES. So you can see what the guest is doing by just looking at the memory and see, oh, this 16 bytes is changing here, it's changing here. So you can have a picture of the guest. Also, the address randomization does not work properly because when you see where somebody is writing something, you can figure out how the layout is. And then you can say, okay, I can do a write there, and then you change 16 bytes randomly within the guest, but probably you can exploit them. Because when you figure out where the global variables is, maybe you can find a spot where you can say, okay, we write here, and then we don't crash, but we figure out now we are running as root or have no secure level or whatever. Because this is all stored in global variables. Yes?
So if you have a dual socket server, how do you get the key material securely from one CPU socket to the other?
Can you repeat the question?
Okay, the question was how do we do it with dual socket servers? So the thing is that there is a PSP, a platform security processor, that's on the CPU somehow. Don't know how it works exactly, then you have to ask AMD. And I also don't know how it's done, the synchronization is done between two sockets, but that's something the platform has to do, or it's not supported, I don't know. As a programmer, you just talk to the PSP generates the keys and holds them within it. So the hypervisor says PSP generate a key for the VM, and then you get an ID that you can assign to the VM. And all the management of that stuff is done in hardware. There's also a crypto processor, which is between your memory, or in your memory controller, between the memory and the CPU, which does all the cryptographic thing, and it talks to the PSP to get the keys. And the idea is that the hypervisor is not able to interfere with that. So it's abstracted from you. So I don't know what happens with dual CPU machines, because that's not a question of what the software has to do. That's somehow synchronized by the machine architecture below. So next step we have to explain is this SNP. And there the idea is that you cannot modify the pages of the guest when you are the hypervisor, because it has a reverse page table, and the page is then assigned to certain guests. And when you do a memory access, then the physical page is looked up in this reverse page table, and the processor will find out that the hypervisor doesn't own the page, and so it will get a page fault or exception, some sort of exception. So that's how SEV is working. We are currently, Hans is working on the IO MMU support, because you need a working IO MMU to get SEV running, probably because otherwise the devices could write into the memory, and we have to protect the memory. But the details are somehow kept in the hardware, so you just have to set it up that it works. And the fourth thing you will have to do is some sort of attestation. So the trust model is that you get some third party which says, okay, this VM is running in this by this hyperscaler and on this CPU, and it's trusted, and nobody can look into that. So the attack would be to have an QEMU or some other single stepping machine, and this one would say, oh, I'm trusted here, and trust me, I run in a supervised or in a trusted confidential environment, and you have to prove that this is the case. But the QEMU cannot prove it. So the idea is that the guest has access to the PSP, the platform security processor, gets out some cryptographic signature that it is running on some of the real authentic AMD processor. Maybe there is also a key from the hyperscaler who says, okay, I'm running at Amazon cloud. I'm not sure how it works. We didn't implement that yet. So the idea is that you can prove that you are running on a real processor that has all the security requirements to make it secure, and you run where you are supposed to run and not somewhere at the NSA in a broken environment. So you need a trusted machine where you make this cryptographic key exchange between the the authentication server and the guest. So you can scale your guests somewhere in the cloud and have one physical machine that makes sure that every guest is truly running confidential. And the way it might be done is, for example, when you have an encrypted hard drive, and all the keys for the hard drives, for the hard drive encryption is at the authentication server. Then the guests go, when they boot, they go to the authentication server and say, hello, I'm running on a real confidential CPU, trust me, here's my certificate, I can sign it. It has been signed by the CPU, and then the authentication server would give back the key for the hard drive. And then you know that only trusted guests can see the hard drive. And if the hyperscaler just boots another one where he can look in by not enabling the feature, it cannot authenticate itself and will not get the key for the hard drive. So that's the idea what could be implemented. So just a little overview.
Other questions? And it sounded like you're waiting on, be it SMP or other features. Is this work in progress? Is there something we can try today?
So the question is what we are waiting for, if we are trying to get other features. So what we are currently doing is getting the basic things in. Goal is to run our appliances in such trusted environments. We build firewalls. We want to have a trust anchor in some hardware. SMP is a thing for us, so probably, our main goal is to run in KVM. And there SMP is working. We just have to adapt the OpenBSD guest a little bit that it can do it, but just adding the bring up code for the CPUs. But this is one track, just getting our appliances running. But the other thing is that we want to have it incorporated in OpenBSD, and there we want to go together with their hypervisor, with VMM. So we implement it in VMM, and we implement it in our in the guest. And the big advantage of this approach is that we understand it. So if you run something on KVM, you set some bits in the kernel, and then something works. But here Hans-Jörg Höxer is implementing the guest side and the hypervisor side. And so you get a real understanding which bit you set here, what affects here. And of course, we don't implement the full feature set. So VMM in OpenBSD can run OpenBSD as a guest, and it can run Linux more or less. So I run Linux there, but I've never tried another operating system, and I think it wouldn't work. So even FreeBSD doesn't work, I think. So we have a limited feature set, but we try to get everything that is needed for all the security in there.
Broadly, what AMD CPU generations or categories have the SEV support?
It's only the server CPUs. You cannot get it on a laptop. And it's the newer ones. I'm not exactly sure where it comes. So all the things I found in my lab somehow can do it, but they also do it in steps. So the oldest ones can only do SEV, the newer ones can do SEV ES, and then SEV SNP are already newer ones. So it's an evolution of their feature set together with the evolution of implementing all the stuff. You start with the basics.
Other questions? Awesome, thank you so much. I appreciate that. Thank you.
Overhead is there to enabling this? How much runtime overhead is there?
Oh, the overhead, yes. Go ahead and repeat that.
So the question is how much overhead is there? You see, we are at the FreeBSD conference. People are talking about performance. So AMD claims it's 2%, maybe true for all the memory encryption, but the main thing is when you do DMA, you have to do bounce buffering. So you have the encrypted page within your guest, and you want to get it out. Currently, we support virt.io. Maybe it would be possible to support other devices, but virt.io is sufficient for all that. So you have to get it out to an unencrypted thing that's done by the guest, because only the guest is trusted. So for each DMA page, you have usually the one within the guest is encrypted, and you allocate a second page that's unencrypted, and you copy it over. So when you read here, it gets unencrypted to the CPU, and the other one is the other page is mapped in clear text. So it's just a mem move from the one to the other, and that costs me in my networking test 10 to 20%. So, and it doesn't really matter of if you turn off this memory encryption or not. So I have a feature in the kernel where I can just set a define to turn off this turn on this bounce buffering all the time, and there you clearly see the overhead of copying memory in and out. And I do networking tests because that's my usual work, making OpenBSD network stack going MP. So I have a lot of testing of that, and there it hits with 10%, 20%, because network is very heavy in copying in or out. If you're just mining bitcoins, probably I think it is not relevant. Or except when you use GPUs, then you still have the problem that you have to move to your GPU. I was at the Confidential Computing Conference. There they talk about confidential GPUs, where you want to protect your training data and your queries to the AI. There they start doing encrypting the PCI bus and then authenticating the GPU. Also, the GPU has a secret, and can it transfer it to somewhere and sign it with something? And it's all very complicated, and we are just getting the basics with the CPU in, and it's enough work.
Super. Thank you. It's a few minutes till lunch. So if I understand you correctly, Bhyve is Schrodinger's book topic. It is simultaneously moving too quickly and too slowly to have a book written about it. Not looking at anyone in particular. Oops. What expectations can we set, good sir? We have Michael W. Lucas here in the room, and you're welcome to come up. I mean, Katja's brave enough to come up. Are you brave enough to come up? Oh, let me get a web page up. Hold on, let's see. MWL.io.
Yes, I'm thinking about it.
What barriers have there been to producing a book on these topics?
I wanted to do it in 2019, except someone was telling me about all the churn in Bhyve and all the activity. And I said, well, that's going to make a book obsolete almost immediately. So I guess I'm not going to do that now, because I decide on my schedule based on what you people tell me. It's horrible when someone listens to you, isn't it? But if nothing else, I have to finish the OpenZFS book, and dog help me, the world needs a approachable DNS book. So perhaps after that.
Can you tell us more about the OpenZFS book? I know there have been a few.
This is a BhyveCon. Okay.
We all
fine.
use ZFS. Come on, get a sticker. I'm going to go Vanna White on stickers here.
The FreeBSD Mastery ZFS books are showing their age. Alan Jude and I are updating that as a single volume.
It's like an update, but again, like from the user's perspective.
User perspective. I do not write programming books
I see.
because I am not a programmer. Or no, I write Perl. My Perl makes small children cry.
Maybe the Perl in general makes small children cry.
It makes old gradient systems cry.
So, there you go.
Other questions? You did 2 editions of Cisco routers for the Desperate? I didn't know that.
Desperate people are, yes, I did 2 editions of Cisco routers for the desperate because desperate people are very desperate.
By definition.
And they will do anything.
Thank you. I know neither of you will forgive me, but I have to live with that. But they all enjoyed it. We have about 8 minutes.
We'll talk later about our vengeance.
Yes. Joran, not quite here. He has some stories to tell about at his company. Other Bhyve surprises, pleasant stories, quick ones as we softly ease into lunch. Yes, sir. You want to come up? Katya proves she can do it. You can do it, Dave. Come on up. Come on up. She's brave. Perfect. I can even. HDMI? Okay, sorry about the blinky, green, and all the nonsense, but good, sir. Yes.
We need the other cable.
You're going to swap out the USB-C. It's on the left. It's on
This one out?
other decimator.
On the other decimator, I didn't know that's a thing.
Black cable, white Velcro.
The green light is very green.
Yeah, I know. Jan,
Very excited. I was going to write my own jails tool, and I thought, well, if someone else is going to write it, I should actually just help them instead. That would be much smarter. Podman is widely used on the Linux world for container-based runtimes. It's an open standard. The Docker project, I think, the other companies, Google, Amazon, Facebook, decided they liked that model, but they didn't like it was run by another company, so they open sourcified everything and took it over, and now Docker is another standards compliant runtime. So the standard is called the Open Container Initiative. Great website, lots of docs, and it supports Linux and FreeBSD hosts, but it uses real jails underneath. So it's the same virtualization that we know and love, but it has the fancy Go-based tooling all around it and wide industry support. So that's Podman in a nutshell. Doug doing the heavy lifting and me doing the documentation and getting it into releases so we can use it. How does it work? There are public container images. You fetch them locally and they're cached, and you can build additional layers on top of the public ones and then push them back upstream to private registries and then reuse them. And the main advantage of this is it's very, very fast deploys. So it's a very different way of deploying software. On FreeBSD, we're used to using tooling like Ansible or Chef or Puppet to bundle software and deploy it. And it requires a certain amount of sysadmin skill and ceremony. And this moves a lot of that effort to a very simple file that any developer will be relatively familiar with. Industry standard tooling, as I said, and also there's a remote daemon. So you can prepare the work on a workstation or in some CI process, and then you can run podman, make things happen on remote servers to deploy them. Just super neat. And the network is a bit flaky here, so I'm going to show this here, and then we're going to try it to see if it actually works here. But is that easy to read at the back? Florian, yep, hands up, good enough. Okay, I can't read it here without my glasses, so. At the top, we're just saying, show me a list of images. Where's the mouse? Hello, mouse. And right now, there are no images in our local repository. So we've not fetched anything from the cloud. And then here we fetch an image. And you can see this one comes from Google Cloud. So in the FreeBSD project, we now publish Podman container images on Docker Hub and Google Cloud, no, not Google Cloud, GitHub Cloud, GitHub Container Registry. If you don't trust those, you can pull and load the images directly from our release artifacts, just like you would any other tarball. But in practice, most people will just use the public ones, and you could actually check these hashes against the release announcement to make sure they're correct. And hopefully for 15.0, I will actually have those hashes published in the release announcement for you to check. So let's assume that's trusted. You can see we pull this image down, and does it tell us how much it pulled here? It probably does on the right-hand side of the screen, which we can't see. There we go. So this FreeBSD runtime is just 46 megabytes in size, and you can see that's a lot smaller than what we're used to. The word runtime is a little misleading. It's not enough to do anything you want on FreeBSD. It is enough to run the package manager and a shell, which would then allow you to run everything you want to do on FreeBSD. So this is kind of like the underpants-only man running through the street at a football match type thing. It needs a little bit of extra stuff to be useful. But the cool thing about it is that's just 46 megs. That's a lot of space to play with. So let's have a look at the next one. We can define these customer images in this thing called a container file. And this is, again, one of the standards that's come out of the Open Container Project. We say, what is the image we want to use? This node toolchain here is new, or will be new in FreeBSD 15. And it is almost everything you need, apart from things that talk to hardware like Chelsea NIC drivers, certain storage-related things like HAST that you don't need. I can't remember if it's opinionated enough not to have sendmail, but I would like that. And it doesn't contain the C compiler. If you need the C compiler and the linker, then you get another 200-300 megabytes of stuff in that image. So we don't ship that by default. There is another flavor called Toolchain, which does have that. It's the kitchen sink. Then afterwards, the usual sort of thing, we bootstrap package, we update the ports, and then we can install Python. And here we clean up our layer, we remove a bit of extra stuff. We don't need the package cache in our final image, so we get rid of that. And then we specify what's the command we want this container to run. And that's it. So we go from an environment where you had to have quite a bit of ops tooling to be able to deploy something like this. And you can explain that to another developer. If you copy paste these things, install the package, add the config file, most developers will have no trouble building that themselves and upstreaming it. So we'll actually run this as an example next, but here you can see how we build this. We tell it podman build. We specify a couple of flags here. No hosts file, and we are explicit about the DNS we want to use. You don't need that, but I like using it because then I know exactly what's happening inside the container. And the most common problems that people have with building containers is that their system hosts file has some sort of weird configuration that breaks inside the container, or they have firewall rules that make DNS more complicated than it needs to be. So that's why I use those two things. And then finally we say, what's the tag we're going to use? I went all out here and call it localhost/test, and we tell it where to find the container file, which is just this dot. Now when it runs, off it goes here. You'll see the step 1 of 5, and these correspond to the lines in the file here, 1, 2, 3, 4, 5, in capital letters from run. And what's interesting is that each of these is built as a separate jail. So there's 5 jails are created here in sequence, and because jails are fast, we don't see any performance hit here. And after each jail is created, Podman Builder makes a snapshot of that jail and then caches it. So if I screw this up and I realize that, oh, way down here, I need to use lang/Python and not lang/Python3, or I need some other port, it will go, well, those other first 3 settings are the same, so I'll just use the cached layer. It's super smart, and then it will just install the extra bit you're missing, and that's really neat. It saves you a lot of time. So we've built our container. We now can have a look, and here we can see, here is the Podman. This is the thing we want to run, and here you can see the intermediary layers that it's created. There's, I don't know, about 8 there, probably because I took a couple of goes to get it right. And here we can also see, here are the containers that we fetched. The runtime one that I started off with, and the no toolchain one that I downloaded later, clocking in at 46 for the runtime and 195 for the everything without a toolchain. That's still less than FreeBSD's base.txe, which is probably half a gigabyte, I guess. And by the time we add Python and stuff into the mix, we're ending up at about 600 megabytes for our whole container. So after we've done that, let's just go and run this. We need a window, don't we? So, window 2. Okay. Put a hand up when you can read it down the back. Keep going up. Ooh. Okay, pretty good. Right, okay, I can read that here. So, same container file. First of all, I need to nuke our...
Is it quick?
It's very quick.
Excellent.
Yeah.
By definition, quick.
Okay, so we're just going to nuke here my existing containers. That just destroyed my local cache and my local registry. So we've got no containers running. We've got no images present. Let's just do that. And off we go. So here it's fetching the images from the registry. And this could be a private one, so this could be a company registry. This could be a private one, this could be a public registry. Either really functions the same way. It's trivial to run one of these on FreeBSD or to use a commercially hosted one if that's your inclination. It's copied the blob, and this point here, it's where it started to cache stuff. Here it's bootstrapping package. And this is probably the slowest piece here. Off it goes on the internet, pulls down all of the package bits, and patience. There we go, installing package, bootstrapping package. It's done another image snapshot here. So that's caching it that it can refer to if we run it again. We saw, oh, okay, it was too fast. Here, it's made another layer for us. It's installing Python. And here, this is my laptop being very slow, writing this out to its little old slow disk. Clean up the cache, tag the image, and with a bit of luck, we can just go run. Okay. And here we have an amazing Python web server that I just coded for you. Okay. That's really it. That's all we need.
Questions? Oh, well, lots of hands. Will you be around later today?
Absolutely, all day, every day.
Let's revisit that after after lunch and the Sylva presentation. Thank you so much. See you in an hour. I believe food is at the entryway.
And again, keep it coming. Just give us 1, 2, 3.
1, 2, 3, test 1, 2, 3, test 1, 2, 3, test 1, 2, 3.
He's coming in on 4.
Test
Something.
1, 2, 3. All good?
Yeah, that's good, working great. Thank you. You can actually go ahead and share your screen if you want. I'll just full screen you and call it good.
Okay.
And it is, oh, we're totally on time. This is weird. Yeah, we'll give people a minute to roll in, Patrick. It's still 2 minutes to.
Settle down, settle down. Thank you again all for coming. This is just so inspiring and exciting and up to the minute, because some conferences have like a 6-month window of preparing and delivering, and like sometimes it's within a few minutes and you get the latest and greatest. And thank you, Dave, especially for having a presentation in a few minutes. That was excellent. So Haizam, I will invite you to introduce yourself. We can hear you in the room, and the simple challenge is I need to repeat questions here at the laptop in front. Okay?
Okay, sounds good. Yeah, yeah.
Are we streaming? Yes, let her rip.
Okay, so I'm gonna be presenting Sylv on behalf of Alchemilla. So I'm Hazem from India, and then we are a small startup focusing on a lot of different solutions, mostly involving IT infra and software, hardware, all kinds of stuff. We'll talk a little bit more about that. And then let's have a brief look at the agenda here. So we'll go into a little bit of a background for my company as well as Sylv, and then a little bit of an introduction to Sylv, and then the architecture and the technology we use to make it possible, a short little live demo, and also some roadmap and work on what we would work on the future, and then we'll take some questions. And another thing, like if you guys want to, you can stop me at any point, ask me questions. I really like that. So yeah. And now coming to our background, so we mostly work with customers who really want like full-blown solutions, mostly like hospitals, schools, universities, who are not that IT-esque, I would say. So we have deployed a lot of VMs on VMware, Proxmox mainly, and we also work on a lot of embedded systems. And most of our focus is on unifying a lot of different technologies together. And you'll see that pattern repeated in Sylva as well. And Sylv, funnily enough, started out as an excuse for me to not use Proxmox anymore. And I was always having small issues with it. Proxmox is great, like whatever they have done in the last few years has been brilliant. But I really wanted a few things that I couldn't really upstream to them because they are a really, really big project involving a lot of different tooling. And I kind of felt that we could make it a lot simpler. And another thing is the fact that we initially thought of using something like Alpine Linux or OpenWRT as our base operating system. And a blocker for us was the fact that we really, really wanted like good ZFS integration. And on any Linux distribution for that matter, out of tree file systems, DKMS, all that stuff, and the inability to distribute binaries to our clients, that was a big no-no for us. So we chose FreeBSD after looking into a lot of other projects as well. And yeah, we have been very happy with it. And the unintended consequence of that was I was not really familiar with networking in FreeBSD. And surprisingly, it's much simpler than Linux. Like for some odd reason, people in Linux land keeps changing the tooling that I like and I use, and that's no fun. So in FreeBSD, it's a lot more stable in that way as a user, I would say. And another thing is the fact that updates on anything, a Proxmox or whatever, just bare metal KVM or whatever it is, was always kind of spray and pray. And I really didn't like that feeling of, okay, updating from Proxmox V7 to V8. I was like, okay, I hope it doesn't fail. I hope it doesn't fail because we had a lot of instances where there were small glitches here and there when updating. And I remember from my past use of FreeBSD, like FreeBSD 12 or 13, updating between them was like a normal thing, just like, an everyday task. And I felt like, okay, instead of building our own appliance, it'll be much easier if we just let that work be done by somebody else. And a little background into that. And once we picked the OS, we started looking a little bit into the foundation, and we noticed that they were accepting proposals of all kinds. Then we already had like a rough thing written for ourselves. So what we did is we they have excellent documentation on how to submit proposals as well. So we kind of took our proposal, put it into that format, and sent it to them, and they were really great to work with, and they enthusiastically said yes, and we've been hacking away ever since. So that's a little bit of background, and now let's come to the introduction to Sylva. Now, there was a small mistake that I made in the inception of the project. I primarily called it a manager for Bhyve jails in ZFS, and now it is kind of a misnomer, I would say, because when we were building these things like VM life cycles, jail life cycles, ZFS life cycles, all these things, the problem was the fact that we needed a lot of tools that the user can use without going into typing in their own terminal commands. Like they should be able to do everything from this one UI. So then we kind of had to implement a nice little file explorer for the user, Samba shares, so that they can set up shares to download VM images or whatever it is, or mount those Samba shares on VMs inside. Like I used to do that a lot with Proxmox, and installing Samba on Proxmox's host was always a battle. And then I wanted a web terminal so that I can connect from anywhere in any laptop in any case without having to travel with my SSH keys. And then clustering was something that we planned for the very far future, but I kind of felt like if I wanted to really kind of dog food this in our company, we really need it because we use that a lot in Proxmox. We don't do much live migration, which is a boon. We do all the HA workloads on like Postgres or something like that, or CouchDB, and so we don't really mind that at the moment. That's that. And an unintended consequence of that was the fact that we are now able to sync configuration between servers, which I'll show in the demo. And we also get a nice single pane of glass interface so that you can there's a multi-master approach here, so multiple nodes can manage each other from their own web UI. So you kind of have to open only one HTTPS port, you can access all the others, which is really cool. And while I was creating VMs, I noticed that I was going into the terminal over and over again to download ISOs for Linux or FreeBSD or whatever it is, or Windows even, and it was a pain. So what we did is we kind of implemented a little torrent client and an HTTP downloader as well, with like progress and all that kind of niceties. And that was really cool because now the whole thing you can do without going anywhere else. And network management, as I said, like we plan to do something similar to like just very basic interface assignment and things like that. But then we discovered bridges and e-pairs for jails and all that kind of stuff, and it was really interesting. And our integration with libvirt makes configuration a lot simpler as well for bridges and things. So yeah, we'll get into that in the demo. And the foundation actually was mainly interested in, or at least the proposal I submitted, as I said, was mostly for Bhyve jails and ZFS. All these things we just kind of winged it, I would say. And then iSCSI support, DHCP server support, the firewalling things are just all things that we would like to see. I will say why we need them as well in the demo. So before that, let's go into a little bit of the architecture and technology behind Sylva. So a lot of people, especially in the VMware or Proxmox space, they kind of go with something that is, I would say, simpler, like PHP or things like that. Mostly like I wouldn't want to say things of the past, but it is not. I don't think it is meant for tools like these because they really start to show their inadequacies, especially when a user is interacting with them. I still have like nightmares of seeing infinite loaders and things like that on Proxmox. And I really, really dislike that. I wanted things to be as fast as possible, and I wanted it to be easy to deploy with the concurrency in mind and things like that. And Go is really fast, really simple, and extremely reliable. And concurrency and error handling, even though it gets a lot of flack, the error handling especially is really excellent, and it is very minimal to build. And, another thing is excellent compatibility with C. So I avoid shell commands like the plague. I try to not do it as much as possible. And to that effect, for PCI pass-through and interface configurations, we wrote our own like small little C helpers that binds with our Go code. So we kind of have this glue code in between so that we don't have to issue fconfig or PCI-conf every time we need to do something. So we wrote all our little helpers in C, which we can really easily call from Go. And then another thing is we implemented the APIs in Go. So the front end is a completely different stack. So it is in no way related to the API, like apart from connecting. And then we initially thought of going with React or something like kind of industry standard in that way. But React, I felt like had a lot of technical debt at that point. I'm talking about like 6 months ago, and it is still evolving, I feel like. And Svelte seemed like a more modern approach to it, and it is extremely fast. It doesn't have any overhead like a virtual DOM. If you guys know about it, it is without any bloat, and we can pick and choose what we want. And the reactivity system, all that kind of stuff is really cool. I can showcase that in the demo. And we go for simplicity first. So that's a big thing, and Svelte kind of fit that mental model for us as well. And another big fact was there are a lot of new frameworks that come and go, but the fact of the matter is if they don't have proper corporate support or things like that, for better or for worse, they kind of die out. And Svelte, since the very beginning, was sponsored or supported by Vercel, which is really big in the hosting space, and they're used by like large companies like Apple Music and things like that. Apple for their Apple Music interface, last I checked, and it's really great. It's cool. And we, after doing some really quick GitHub and paper math, I figured out that we might be the third largest open source Svelte 5 repository, which is kind of crazy because it didn't feel like it when writing it. It's been a pleasure to work with. And yeah, so I think now we can go into the demo. Any questions so far? Okay. So let me just take my first node here. So this is kind of like my little home lab that I set up for this presentation. I have just 2 nodes here. I purposely picked 2 nodes because I'll make a lot of people mad because it's not really a cluster then. And the thing is, it is true that without 3 nodes, you can't make a quorum. But we know that users are going to do this anyway. They're going to try this out. They're going to break stuff. So I figured like I always do this thing where I do the mistakes like how a user would and then kind of work around it. So now it's really simple. Even if you mess it up really bad, even if a node goes down, it is easy to recover from because we kind of, dog fooded that and made it work. So now we have 2 nodes here. One of them is Loki, and another one is Sylvie from the TV show. So let's go over the interface one by one. So this is the dashboard. Like we source all our information from either sysctl commands or ioctls or something like that. As I said, some C glue code is there to interact with the operating system. And the best example of that is interfaces. So all the interfaces you see here are there on my system. And we don't pull that from fconfig or anything like that. We use libraries that are meant for fconfig, but not anything else. No shell commands here. So it's really fast. I can update it like every second or something like that. And I can see like what flags are on this device, all this stuff. You can just pull it directly from there. And the glue code. And then I really liked how VM Bhyve, which is very popular in the space, managed networking for VMs and not VMs. And they have this switches thing. I got a question on Netlink to it. I'm not using Netlink yet, but sorry, I got this question on Zoom. I'm just answering that. Question is, are you using IOCL and routing sockets or Netlink to inspect the network state? Right now, I'm not using Netlink, but we really plan to because I think that's kind of the future. We're using IOCLs and routing sockets now. So yeah, coming back to this, we have manual switches, which is basically like bridges that you can import into Sylv, kind of like how Bhyve does it. And we also have standard switches where you can kind of make your own little switch and assign IP addresses to them, or run DHCP over them, SLAAC over them, whatever it is. And you can pick any port from within the system you like, and then let's make it happen. So this switch here is a private switch. Private in the sense it's not connected to any port. I just connected to this VM, and then the VM makes like tap interfaces to interface with them, and that is handled beautifully by libvirt. And yeah, that's about it for switches right now. I'm planning on adding bonds and things like that, kind of like how Proxmox does it, because we have some customers who use like LACP and LAGG and things like that. So I kind of don't want them to go into terminals and set up a bridge there and then come back here and import it here. It's not our style of doing things. So that would be something that we would work on. And yeah, and the objects here is for not doing the same thing multiple times. Like I really liked how aliases worked in pfSense, and it's like define once, use everywhere, and I really like that concept. So what I did was, since we will have a firewall and traffic rules and all that kind of stuff, I figured we could have something similar to that, something simpler as well. So you can define MAC addresses here, you can define networks here, subnets here, you can define hosts here, and you can use this throughout the application. And when you change it here, it automatically updates everywhere else. So if I set up a MAC address here and I change it here, if I'm using it in 2 different jails, hopefully one of them is not running when the other one is. It'll just change magically, like without you having to go there and change it as well, which is something that I faced over and over again as an issue on Proxmox, because they have text input fields everywhere, and then I kind of have to remember what I gave in the other place so that this doesn't break. That's one thing. And yeah, so that's a little bit into the networking. There's a lot more stuff going on underneath, and now I think we can go into storage. So this is the Explorer I was talking about. So this is like, because I wanted to see some config files that I changed. So if I go here into Sylva, I can download my license file or anything like that, and it just works. It's not that complicated because we don't have like multiple select here working right now, but we really want to download, copy, paste, delete, all that simple functions to work, right? Because I don't want to, again, I don't want to open an SFTP connection just to do like a simple download. So that's where this kind of came in. And then when we go here, we can see disks, all the disks in my system. I got this SSD in it that is not used at the moment. So what I was planning on doing was, let's create some partitions on this disk and then make a ZFS pool on it so that I can showcase a little bit of the features. So now we can initialize GPT on it, and then let's make some partitions. Let's make this 8 gigs, 8 gigs, 8 gigs, 8 gigs, 8 gigs. So now we have 5 partitions. We save them and they show up here. So now what we can do is we can actually use these partitions as disks so that we can set up a nice little ZFS pool with like different kinds of RAID configurations, Z-RAID configurations. So we'll go into pools now, and when we click on new, you can see that we can have any number of VDEVs as we want. And this is something that you can do on Proxmox, but it's not visual, so I always mess up when doing this. When creating pools, I always have to do it like 2 times, and this is nice. So before that, I forgot to show that's a nice little dashboard here. We'll probably add more graphs here, and since I have a lot of jails running here, and I enabled deduplication on the dataset or the pool, and all of these have very similar kind of base. I'm not using a different base for each of them. So, it easily gets deduplicated, saves me a ton of space, which is kind of cool. And going back to pools. So if I drop in, let's assume these are disks for now because I don't have many disks. So if I put in 3 disks here, I automatically get a RAID Z option. If I remove one of them, I get a mirror option. Alone, I don't see the RAID Z anymore. And if I drop in, let's say 5 disks, I see RAID Z 2, 3, and I can make n-way mirrors out of it. And if I really wanted to, I can select spares here, and then I can select if I want them to auto replace and things like that. So let's just make this RAID Z. You can see that the redundancy changes, and I click on each of them. The striped, I get 24 gigs, which is right. Mirror, I get 8 gigs because it's an n-way mirror if I really wanted to. And let's call this Zagreb. Okay, it's a mirror. And let's not have spares now. And great. So another thing here is for ZFS, since we don't have access to libzfs, we kind of are forced to run shell commands. And the problem with that is that the output for some of the ZFS commands or zpool commands or zdb commands or whatever it is not really right. I would say they're doing some work on giving us JSON output and things like that, but I feel like it's never going to be as easy as like how we do network interfaces. It has been rock solid because we get access to the libraries as is. Like we heard it in the talk yesterday that Michael was talking about, and Jan as well. It is really cool to be able to interact with it directly, and I hope that is done in the future because I would rewrite the funny thing is, I think we built the most feature complete ZFS library in Go. Like anybody can use it right now. It is actually a fork or something else, which was not really feature complete enough for us. So we built on top of that, and we added in a lot of features like disk replacement and things like that. And still, I wouldn't consider it really good because I really don't believe shell command outputs to an extent, but that's how everybody does it. That's how Proxmox does it. That's how we do it. That's how anybody who's working in ZFS does it at this point. And yeah, so that's that. And we can see nice little status here, and we can scrub the pool here. Since we don't have any data, it completed really quickly. Status scrub on this one, and you can see that it shows a nice little progress indicator, and that is all running in the background. You don't have to stay there in the UI, so the state will persist. Come back here, you can still see it moving, which is really cool. And then yeah, so now you can scrub it again if you like. It auto disables the button so people don't click it over and over again, which is something that I've done in Proxmox before, and it has caused issues. So kind of let not people do that. And then coming to datasets, yeah, you could replace this here. I hope it works for the demo. Yep. I'm not sure. I have never replaced disks using the UI on Proxmox. I'm just too scared to touch it. Yep. Do you handle disk replacements? Yes, we do. We just replaced one disk here now. Let's do one more disk replacement. Let's replace it to P3. So you can see that P3 is new, P4 is old. It's doing the replacement right now. Yep, it's replaced now. Now it's 3, 2, and 5. And yeah, it also supports like status for replacement. You can see that there was some resilvering happening because I replaced the partitions. I mean the disks, which are partitions. So yeah, that's about it for the pools section. There are some other nifty features like we support some more options here, which I think would be useful for users. But Proxmox kind of gives you only a shift and I think trim, maybe auto trim. And the good thing is that implementing more properties here in the advanced section is not that difficult. It's like a 2-minute task. So if anybody wants like if we find that there is a requirement that users can actually use it, we would add that in like 2 minutes. And the backend supports all properties by default. So if you're using an API to interact with Sylv, it's already done. So that's that. And we come to file systems here. So this is what I really wanted from the beginning on Proxmox. So I wanted to see the hierarchy of each file systems. I wanted to be able to delete them if I wanted to multiple datasets at once. I want to be able to edit the properties of just one of them as a child, or I want to be able to edit the parent and then cascade those changes down, which ZFS already does. All these things, I really didn't want to access the file system, the terminal to do that. And that's what we implemented here. And this is still incredibly fast, but not as fast as it could be if I had the libraries that I wanted to work with. We have had users who had like thousands of snapshots and it loads in less than a second, less than 500 milliseconds, if I remember correctly. And they're very happy with it. And yeah, so this is my jails data set. So, and underneath I have all these data sets which I use here. We'll come to that. And then going to volumes, just like file systems, you can create volumes on any pool that you like. Let's make one now. Let's call it Croatia. Let's give it 8 gigs. Oh, let's give it 4 gigs. I don't know. And we can select which volume mode you want. And we figured out in the calls that if you don't give dev here, FreeBSD kind of starts running some stuff on it, like, I don't know, statistics or things like that. And then we won't be able to access it from the VM, or it won't show up as a device that we can use. And we added this flag here, so people can, it's auto selected because we assume that people are going to use this in VMs, but you can always change that there. And then metadata is only cached so that by default, so that it doesn't cause issues with other file systems running within VMs. Just like simple nice things that users don't really have to worry about. Then we create here and it just shows up. And we can flash an image to this volume that we just created. So I have OpenWRT downloaded here. So what I can do is, instead of like, OpenWRT is one of those operating systems where you don't have an installer, you just flash an image over a disk. And that is really nifty for us because there are a lot of distros that provide images, especially like Debian or Ubuntu or things like that. And flashing them is simple enough. Like, now it's flashed. Now I can use that as a disk in one of the VMs or wherever. And yeah, so that's it about pools, I think. And then, another thing is we have encryption support in the UI. So Firefox is filling in my password here. But if I click here and then you generate a new password for you, it does all the handling for you. So you don't have to worry about that. It backs it up into somewhere in the file system as well. Yeah, so that's that. And then coming to snapshots, I had this job running since yesterday. So we support like instantaneous snapshotting, like where you can just snapshot at will, or we also support intervalled. I don't know if that's a word. Snapshots where you can specify either a cron expression, or you can select a simple interval from here, which I like to do. And then you can see that I'm snapshotting Postgres jail every hour. And I gave it a prefix Postgres hourly. And then it generates this nice little string at the end so that all of them are unique. And yeah, so that's about it for snapshots. Like, you can select any pool that you like, any data set you like. It supports volumes, it supports file systems, all that kind of stuff. And then you can delete multiple snapshots together. So let's delete these. It's gone. And yeah, so that's that. And then coming to Samba. Sorry?
When you know you have a quiesced VM?
We should be able to, in the next few hours, I can add that in.
Thank you.
It's a nice little feature, yeah. We should be able to do that, yeah. There's no blockers for that. That's pretty simple. And all of these are running on their own little threads in Go, so it doesn't block the main application flow. So everything works as is. Since Go is multi-threaded and nothing blocks each other, It's a little bit racy, but nothing is ever blocked. And then coming to shares, we really wanted this feature because we use a lot of Samba for a lot of our clients, and most of them really only require like a few shares with a few users and a few data sets, a few directories. So here is something really, really simple. It's not like true NAS level or something like that, but it's there, and we can add groups into it, and we can even manage authentication here. So if you really want, I added myself as a user, and we also added in some nice little audit logs. And yeah, and this is using some VFS add-on, I think, and we can select which interfaces it binds on. So it's not that noisy. Samba is very noisy, but we can kind of restrict that to an extent. So yeah, I know most people in this conference might not be interested much into Samba, but it felt like it's really cool. And then what I talked about earlier, you have a nice little downloader here, so you can just paste in an HTTP URL or a magnet. And we don't use any external torrent downloaders or qubit torrent or anything like that. We implemented a small little client using another library, which runs its own a daemon inside of it, which lets us download torrents, add trackers, all that kind of stuff. So that's that. Now I have 2 images downloaded here, and that's about it. And then coming to PCI pass-through, this is where I mentioned where we wrote some custom C code to interface with the operating system. So in this case, you can see that my USB bus is blue here. So what that means is I have taken it away from the host and I've prepared it for being passed through. So where I'm using this is in my OpenWRT VM. If I go here, if I get access to the terminal, yeah, let's see, ls USB. You can see that there is a Realtek Bluetooth and Wi-Fi adapter. And if I do add a playlist, you can see that it works fine. And in the OpenWRT UI here, this is the VM that I'm running. You can see that that radio, that Wi-Fi radio shows up here, which is really cool. And pass-through works the same way across other devices as well, at least in the UI and the backend. Like in this case, we can see that there's an NVIDIA card being passed through, taken away from the host. And I passed it through to the Windows VM here, but I was having issues, so I kind of stayed away from the demo for that. But we'll try doing that maybe towards the end. So yeah, PCI pass-through. Yeah, so this is really simple. It's really fast. If I wanted to disable it, I can just click here and to disable that. It'll take it away from the VM. If I try to do that now, it'll probably tell me that it's in use. Yeah, so I can't remove that. If I stop the VM, then take it away, it's fine. So that's that. Any questions so far?
We do have a question, yep.
Can you also pass through serial ports?
Question, can you pass through serial ports?
The thing is, we don't discriminate like what you're trying to pass through. If you really wanted to, you can pass through the bridge or like the SATA device or whatever it is. It's up to you. If it works or not, it really depends on Bhyve and the underlying stuff. We have tried passing through USB, graphics cards, and hard drives, especially a lot of hard drives, and NVMe storage. Like we have tried those. We have not tried serial yet.
But fundamentally, it's PCI devices, and if it happens to be the serial interface, great.
Yeah, exactly. Yeah.
We have another question.
How clustering works, if it works.
How does what work?
Clustering for high availability. In the beginning,
there was mention of that. Okay, so when the time is right, describe what it does and does not do for clustering.
Okay. At the moment we support adding storage configurations. I would say this is mainly for the fact that we wanted to back up VMs, kind of like how Proxmox does it, to PBS, but we didn't want to write something like PBS yet. So we have S3 and directories ready now. And in the next few weeks, we are implementing periodic or whatever kind of backups you want from each of the VMs and jails here. So that is the first kind of implementation that we'll be using clustering for. So the thing is, the way how Proxmox does it, like I think I'll explain that a little bit. So they use something called CoroSync. It's another application that manages this stuff for them. And we really didn't want to add that dependency on CoroSync. We kind of wanted to do something else. So we use something called HashiCorp's Raft library. And underneath, what it does is it runs an SQLite database, which has config stored within it. So what happens is when you hit some endpoint that is cluster specific, like creating a VM is cluster specific now. Like you can select which node in the cluster you can choose. So that is possible. Or if you wanted to, you can add things that are within a shared storage, I would say, a shared config base. That's what we built right now. And on top of that, you can build a lot of cool things. Like, as I said, storage is a big thing because we kind of want to define it once, use anywhere. And then all the jobs, successes, failures, all that logs, we can store it cluster wide so it doesn't get lost if one of the nodes go down. And we don't have to manage them one by one in each of the nodes. And we're also planning on implementing cold migration using the cluster code that we already wrote. So cold migration would work as in like the node discovers another one, it sends them basic configs for the VM, checks if everything is right there, and then ZFS sends the data set or the directory that the other person, the other node needs, and then kind of works around that. So that's where clusters would be used. And right now we implemented the bare bone stuff that we kind of need to make things like SPOs, the single pane of glass that you're seeing here, and config sharing work. I hope that answers your question. Yeah. Any other questions?
Another question from the same gentleman, yes.
Is it production ready?
Do you consider it production ready?
Oh, at this moment, I wouldn't say so because we started work on this only like 4 months ago or 6 months ago, I feel. Yeah, 6 months ago.
The clustering or Sylva in general?
Oh, clustering, I think it's in the last few weeks.
Okay.
So yeah, I wouldn't say it's production ready. I would wait for the backup stuff to be implemented because we discovered a lot of bugs while we were implementing that in the clustering thing. We fixed all of that. So I would say like maybe next month I would release the v0.0.1, which I would consider semi-production ready, where we would deploy it ourselves on some of our customers that are looking for VMware alternatives where they don't have much bells and whistles being used. Most of them are like single nodes. And another place that we were really pushing forward for is, I might be going on a tangent here, but like I really wanted to mention this, is like small little VMs that run on Hetzner and Vultr and places like that. Because a lot of people, especially in India, they buy these cheap nodes and they kind of want to run Proxmox on it, which is really not going to work because Proxmox being Proxmox has a lot of different dependencies, and I don't blame them. They do a lot of stuff, but they really need something lightweight to run on these like 1 gig or 2 gig VMs, and some of them don't even support nested virtualization. So jails kind of are perfect for it. LXCs are perfect for it too, but there is no easy way to manage LXCs alone with Proxmox, and I'm sure it won't run on a machine with a single gig RAM and half a vCPU. And we're targeting a lot of that base as well. So yeah.
Did you
so
mention?
I would say production ready in like a few months or like maybe November, I would say. As we reach ports at least by then. People can try it out. We'll be confident in letting people trying it out.
Did you mention ARM64 in the Hetzner and Company? Did I hear you right?
Yes. That's another thing. Yeah. ARM64 VMs are really, really cheap, and they are really, really nice because on places like Hetzner, what I've noticed is that people have this dislike towards ARM. I don't know why, because most of their workloads will run on ARM anyway, and they choose not to use it, and it ends up where in a situation where people like Hetzner, they over provision AMD 64 hardware, but like the ARM64 clusters are like not used at all. So you don't have any noisy neighbors on ARM64, and they're really cheap because I don't think there's that big of a demand yet. And Sylva works perfect on those machines, and they have been great. I tried it out a few times, and jails work great as well. It's really, really lightweight. Sylva uses maybe like 128 megs of RAM at most if you're using like multiple jobs, heavy clustering, like 10 different nodes and things like that. Even then, the memory footprint, the CPU footprint is really, really small. And since it's all contained, you kind of get the advantage of not having to install many dependencies as well. So that's that. We have some build issues on ARM64 because of a dependency that we have on the front end. But that doesn't really matter to the end user because we're going to be packaging it up with Go anyway. So yeah, that's that.
So if you're looking at these VPS services, does this mean you might have a headless sort of command line version, or purely use the GUI?
Oh yeah, definitely the GUI. The GUI is so lightweight, like the entire GUI strips down to like maybe 3 megabytes.
That's cool.
And that is which is delivered to the client. So it really doesn't make that much of a difference shipping only the GUI, only the CLI versus the GUI.
2 questions.
Like if they, like for GUI, if they wanted to use CLI tools, why not just use LXCs? The whole point is this is a new market. I think that nobody's really looking into, especially in countries like India, because I've noticed this a lot where there's a lot of these small nodes being sold, VMs being sold, but people kind of give up on them because, nothing really runs on them properly. I think this would be a nice little solution to that issue. And Hetzner has images for FreeBSD as well. That I don't think it's like officially supported, but like community maintained, which is still pretty good. The latest ones are there. So yeah, and since we are not like our own distribution, we don't have to worry about having to get people like Hetzner or DigitalOcean or Vultr or whoever, or Contabo is really popular in India for some reason. All of these folks, they can just run FreeBSD and then install this on top. And it's pretty simple to configure as well, at least the initial setup. So that's that.
Yeah,
Okay.
I'm wondering from dev viewpoint, I really love the various design decisions, but when it comes to testing, especially automated testing, I'm wondering if there's already a plan to basically incorporate the whole executing something on the GUI, it goes to the back end and then interacts with ZFS, for example. I would be really interested how to test something, maybe in an automated manner. There's already some ideas from the team.
So I don't know if you could hear that, but the question is, what does automated testing look like such that something at the front end can push its way all the way down to ZFS and work it and go full circle to make sure you're genuinely testing it, perhaps?
So the thing is, since the front end and back end are so well separated, we don't consider the front end something that is even noticed by the Go backend at all. It is just a user of that API. So we only really have to test the back end of things, because if the API is stable and battle tested, the front end can only do so much because we are connecting via the REST API, right? So, and we put in guardrails wherever we can, as we saw in the PCI pass-through stuff and things like that, which if you try to do this, it's not that the UI fails, it's that the backend fails and tells the UI that, okay, I'm not going to let you do this. So when you test for things, you kind of have to only test for the backend part, right? Does that answer the question?
Normally, because there I would see like similar issues if you test it automatically, because just getting, for example, a state where you know something will positively fail and is repeatable, I would think this would require some infrastructure or something like that. Maybe I also see it wrong, but I would just really love to get some insight into then how the tests are written and executed.
What's your use case for the testing? What's your use case
Use
for
case
testing?
or what?
I'm going to ask the audience member.
Mine is mostly from a dev perspective. I'm also interested for maybe something similar. I have a Go library that interacts with OS components, and I would like to automatically and repeatable test these and also test for known issues, for example.
Okay, so he has a Go library that interfaces with OS components and, for example, wants to see what a known failure case looks like that can be reproduced, hopefully until it goes away. And it sounds like perhaps you have something that might benefit from this API under the hood, if I'm reading you correctly.
It's an interest of mine, and I'm
cool.
looking at this really great project. I'm thinking, oh, maybe they have something up their sleeve that would be interesting.
Well, get in touch, join a call, jump on Discord. I hope that helps.
Yeah, we really did some work on, if I get the question right, we did some testing with a lot of mock interfaces in Go. You can, they have their own little testing suite that you can use, which we depend on for some of our packages. And what we do is we mock everything. We mock the outputs that we might get, the inputs that we might give. That's how we primarily do testing, and we have not done that much testing yet. So yeah, I would say if you're really looking into it, I would use just standard libraries for Go, and that has not failed us yet. And we have written a lot of tests in Go, like especially on embedded devices like running OpenWRT and things like that, where you kind of are constrained, really constrained with like maybe 32 megabytes of RAM or 64 megabytes of RAM. And test there, even then, it's really fast and really nice. Even mocking things are pretty good.
And I'll just speculate that testing is a great way to get involved and be a hero. Just saying. Yeah.
Oh yeah, that's another thing. Yeah, true.
Open a quick one. If I log into the FreeBSD host system and adjust something, would it be reflected on the GUI and vice versa?
Which subsystems? Networking, anything?
If I SSH on my FreeBSD host system and I adjust something, would it be reflected there and vice versa?
The question is, if the administrator were to SSH into their FreeBSD host, would changes be reflected in the GUI? Would they break it, like was the case in, say, FreeNAS early days? Or what can and cannot one do safely through the host command line?
That is an excellent question, and that is something that we have worked so much on. So ZFS and VMs to an extent support, like some sort of, like you can do whatever you want with ZFS. Like if you change some properties or if you change some pool stuff, like anything that you want on ZFS you can do, because we don't change anything, that we don't add any special properties, we don't add any thing to our DB or anything like that. This is whatever you see in front of you is live from the machine. So if you, for instance, let's go here and zpool delete, is this the command? Zpool delete.
Feature request, does the built-in terminal have font size adjustment?
I could add that. What is the zpool command for delete?
For what?
Someone help me out here.
Looking for destroy? Delete, destroy?
Yeah. Zpool, destroy.
Destroy Zagreb.
Destroy Zagreb, right?
Yep.
Yeah. Okay, so now we destroyed that pool. If we come back here, it's gone.
There you go.
Yeah.
Cool.
So ZFS is rock solid in that aspect, because I was really particular about that, and it was not easy to do. To not have any properties that are kind of, I wouldn't say proprietary, but like custom, that like maybe like how TrueNAS does it. But yeah, that's that. And the VMs, you can add, I mean, since we use libvirt, you can obviously edit like.
And when you have a chance, tell us about libvirt, because it's been sort of ignored on FreeBSD because no one was consuming it. You're now consuming it, and the developer is now responding to your needs. It's pretty cool.
Yeah, that's actually really cool. I didn't know that the Free Foundation was sponsoring this work until I saw his commits, which is really cool. So what libvirt does for me, at least, is provide structure. Like, I really like the fact that I can bring my knowledge working on other, stuff like KVM or KeyMem, for example, and they have support for that as well. So for me, it was one, the transfer of knowledge. I know exactly what XML specs work. I know what doesn't. I know how to give it. I know how to take it. All that kind of stuff. I don't have to relearn Bhyve config, which is not that big, but regardless, onboarding new people is much simpler. And the second thing is, I really like how they handle networking. I don't have to worry about making the VT nets or tap interfaces. I can just give that here and it just works. I don't have to worry about bringing them up, bringing them down, things like that. And what else is there? And yeah, when live migration or when domain information like CPU, RAM, and things like that, I don't really have to run these commands myself and then pass the output and things like that. I can always just read it from the nice little tools that libvirt gives me, which is really cool. And yeah, and if I really wanted to, as you can see here, for this VM, I'm using ZVault with the VirtIO block library. I mean, not library, the emulation type. And since I think libvirt supports that, but I wanted some more flexibility here in terms of assigning the IDs. What I did is I added them as extra arguments for the Bhyve command that libvirt runs for me, as well as the VNC thing here, because for some reason they were not supporting resolution or things like that. Maybe I don't remember exactly, but yeah, that's that. And then pass through as well. I don't remember seeing pass through being supported by libvirt yet on Bhyve, so I can just add that here. So any Bhyve config flag, I can just add in here without much issues. So three things: structure and the ease of use for networking stuff, and the extensibility with this little block here. Those are the three main reasons why I started using it. And for the future, I think when things like live migration is implemented and things like that, it'll become even more nicer because it will support those things by then as well. So yeah, okay.
Yes, Sven.
Thank you. Such an amazing project, the best I've seen
It's
in a month.
not a question. It's a thank you. Such an amazing project from Sven.
No, thank you for that.
Exactly the correct direction.
He calls it the correct direction.
A lot of these things, like I wouldn't take credit for, like is the UI. The UI has been heavily inspired by Proxmox because I really like it and they have done some things right. But the things that I would take credit for is making things faster. Like everything is like instantaneous, like rating pools, pass-throughs, all those kind of things. Because I really, from a user's perspective, they don't really care how it works underneath. Especially like in the home lab community, as long as it works, that's all good. So that's that. So now I think we can come to demoing some VM stuff and jail stuff. I have a Debian VM running here, which I flashed their cloud image on. Right, yep. And I forgot the password, so I can't log in. But yeah, it works fine. You can attach detach storage. You can attach PCI devices and things like that. And networking, you can have this VM attached to a switch. So there's kind of this mental model that is being made. Everybody knows what a layer 2 switch looks like, but most of the people don't really know what bridges are or what e-pairs are or what VTNet interfaces are or VNet interfaces. Nobody cares about that, but everybody knows about switches. So when I demoed this to a few of our customers, they were like, okay, oh, so you connect, they just immediately tell me, okay, so you connect the VM to a switch. It just makes sense to them, kind of like VMware or something like that. So, and we stole that proudly from Bhyve, the idea at least, and then, worked on our own little implementation, and it works well. OpenWRT is using a manual switch called WAN, and it auto-generates a MAC address for you. And we spend a lot of time working on MAC addresses because people like Hetzner don't really like it when you use MAC addresses that are not yours or assigned to you. So that's that. And when we come to the VM here, you can see that it is attached. This is my WAN network at home, and BR WAN is the bridge that ETA0 is associated with. So it just gets an IP from my main router there, all working fine. And what we're implementing in the next few months is a DHCP server within each node. So what you could do is you can have a switch like this without any ports attached to it, and then attach this to your VM and run a DHCP server on the switch. So what happens is the switch, I mean the bridge delegates an address to the VM, and then you can kind of do NAT rules within the UI. So you kind of get routed networking for free without having to run an extra VM or an extra jail, which comes into use in the resource constrained environments that I mentioned earlier, where you don't really want or need to run a whole blown firewall distribution like OPNsense or PFSense or whatever it is. You can kind of just do this because most of the people that I've come to know just use three rules in their firewall. One is maybe CrowdSec lists. Second one is NAT rules, and the third one is just bare minimum traffic rules. They're adding some stuff like GeoIP things, but yeah, mostly simple stuff and something to get them up and running quickly. So that's that, and I think we'll. So creating VMs are just as simple. You pick which node you want. It's giving us this option because we're in a clustered environment. We pick Loki here. We can, and when you click Loki here, what happens is all the options from here changes. So now you see we have only OpenWRT. Let's go into Sylva, and then it should change here. Oops.
More question coming, and we do have the other presenters ready for the next slot. What's your question?
Are they doing the SSH keys injection?
Question from the audience, are you doing SSH key injection?
Where?
At which point?
At the point of creating a VM so that they can SSH.
Ooh. When creating a VM, can you inject a key into the either image or ZVault or something?
I actually looked into that yesterday. As I mentioned, this Debian VM right here, right? What I did was I downloaded an ISO, a cloud ISO, okay, and I kind of flashed that onto my disk, hoping that they would have set a default password. I quickly realized that they don't set a default password, and you have to inject it like the gentleman just told us. So that'll be something that we're working on because that's pretty cool and it's actually really useful.
And Dave, you have
that
some
will be probably supported.
ideas?
Yeah.
So that's actually support for the CloudInit sort of interface, CloudInit, and on FreeBSD we have nuage-init, which is an in-base implementation of parts of that. And in general, it requires you to either have a metadata server or to create a small fat CD-ROM image.
Got it. So Dave says there are a few options on FreeBSD. There's CloudInit and then nuage-init, which is in base, allowing for that, and you can have either a metadata server or a fat image to pull from.
Yep. There are a lot
Or
of ways
CD.
to do it. Yeah, Dave was right. Yeah.
Okay.
It's just that we have been hacking away at this for so long that when we get customer requests like not customers, like users and customer requests like these, we kind of look at it from a perspective of everybody involved, and then we implement as we can go. So a lot of these things we implemented based on customer feedback. One of them was the downloader, the other one was PCI pass-through, things like that. So yeah, keep them coming. Like you can join the calls, request your features there. We will definitely look into implementing them.
Well, cool. Thank you so much. Let's thank Hezam and move on.
So I hope that demo was somewhat okay. And
sorry, what was that?
The demo was okay, I hope.
It was fantastic.
Yeah, now looking at the roadmap, the first thing that's on our list right now is completing the backup system, because that's what we need for implementing it with some of our customers. And then, as I mentioned, the DHCP server and firewall management, simple stuff. And then, thanks to DCH, we have been able to work on that ports, to get it into ports, which is really cool. So users can just package install it. And ISQC support is something that some of our customers wanted, and we'll be working on that. WireGuard is just because I love WireGuard and I want to do it. Then ZFS backups, we're still investigating things that we can use, some stuff that we like, some stuff we don't like, and then we'll figure something out for that as well. So all of these, I would say, would be in the master branch by maybe next year, mid of next year, which is what we're targeting. And that's it. That is my presentation, and special mentions for all of these folks listed here: Ed Mass and Joseph at the foundation. They have been great to work with, and Michael Dexter from CFT. He's been also very great. Jan for helping me with jail stuff. DCH for giving us insight on clustering and ports and everything else. And some of the users from our Discord who has been testing along with me and the folks at my company. So yeah, any other questions?
Oh, yes, Mecca.
Once you get to the cluster backup, can you please consider how it's called? ZFS healing receive.
Healing receive, okay.
Yeah, there's a feature that you can send data snapshots to the other server, and if this one gets corrupted, you take the old one back and it heals itself.
It's called resumable streams, isn't it?
No,
Healing rather than resumable. Okay, so you will definitely receive some feedback and requests when it comes to the backup server, specifically the healing send and the reversed healing.
Yep. We have actually looked into that extensively, and that's why I pushed it so far back in our roadmap, because it's really easy to do, but it's really difficult to get it right. So I figured we'll just get the feel for how customers would want it, and then kind of work our way around it. So yeah, but yeah, I totally understand why that would be needed. Yeah. Yep. Okay.
Perfect. Hello, can you hear me okay?
Hello.
All right. Hey. Mm-hmm. Sounds good. Yeah, I've got to level set, Michael, I've got so there's a couple things kind of starting. We're in the process of coming out with our first POC release. So what we've effectively had, of course, is there's been a lot of eyes on our product from VMware. They're crawling all over our page and our profile, and they're trying to figure out what. Yeah, no problem. So yeah, Ian Evans, I'm CEO for Kerios, and really what the company is we formed about 4 months ago, and the purpose of the company really was a couple things. One is to essentially produce a hyperconverged infrastructure that uses Bhyve at its core, that is very much focused on the data center. So we're kind of pushing into the hypervisor space, but we're also pushing into the data center information management space. So much broader control over the larger data center. So we've been at that, yes, like I said, for about 4 or 5 months now, and very aggressively developing with the intent that, we're going to be pushing out a POC in pretty short order here, probably in the next week. So we're looking forward to doing that. Chuck, if you want to go ahead and introduce yourself.
Yeah, hi, I'm Chuck Tuffley. I work with Ian at Kerios, and in my copious free time, I'm a FreeBSD committer. I've worked on Bhyve and NVMe things in the past.
Perfect. Yeah, and like I was saying, Michael, so we're kind of right now we're in that position where, like I mentioned, we have a lot of the big companies kind of crawling all over our stuff right now. They're trying to figure out what we're doing, and we're trying to be a little bit careful in terms of what we actually release, moving forward to the POC, and then kind of just like get it all out there at once within the community. And then we're also working on, as we speak, kind of our open source strategy, what that looks like, what we're going to effectively release. There's going to be parts of the product that are available in the open source community. We're going to have an open source community edition of the product. And then, of course, there'll be tiered, like Proxmox does almost, where, there's a tiered licensing that you can effectively purchase for the product. And then that would be on like a per socket basis. But that's kind of where we're at right now. So I was going to present just at a very high level. I can obviously show some screenshots of some other stuff, but I definitely want to at least discuss the platform so everybody knows kind of what we're building, some of the features that we're coming out with coming up to that POC, if that works for everybody.
Hey, Ian.
Perfect.
Hey, Ian.
Okay.
What is a POC?
Proof of concept. Sorry. So the idea is we're basically going to get it to some people to test, and really what we want to be able to do is get the feedback loop going. Specific gaps, any bugs, anything that needs to be addressed before it actually starts to go to market, and we start to get more community involvement in the product. That's the purpose of the POC. So right now we have about 12 or 13 lined up. Fairly seasoned users in the data center space, people that are notoriously frustrated with VMware, and they're very much interested in alternatives to evaluate the product. So that's what we're doing with the POC. Cool. We still have everybody? All right, give me just a second here. All right, can everybody see this? Okay, so a couple things right off the bat. We're both a software and a hardware company, essentially. What we're doing is we have what you guys will see pretty quick here is a downloadable version of the product. You can go in and download it, use it, and evaluate it freely. There will be an open source version that's going to be available, like I said. And then we also have a hardware element to it that we are effectively building as well. That's kind of like in more of a ruggedized type solution. But really, it's just a level set on the product. Like I said, it's a hypervisor, a platform itself. So it's very similar to what was just presented. We do a lot of the same stuff, as Proxmox or, ESXi. We're trying to release a competitive product there. But we're also very much focused on reducing some of the barriers to entry within the data center. And that's been a huge focus for us, is addressing things like liquid cooling, energy efficiency, carbon usage is a big one that we're focused on. And then we're also focused on adding some additional security tools into the actual hypervisor itself, beyond just, patching and providing security patches to customers, but actually providing a framework that allows people to scan and remediate based on the CVE databases and other security databases that are out there. The objective is you pull those in, you can go ahead and scan the hypervisor itself, then also scan the virtual machines, and then be able to assess the security posture based on what we consider OpenSCAP or oval databases that are available through NIST and DISA, and there's a bunch of other ones. But really kind of assess the overall security posture of the environment. And then the other piece that is pretty interesting about our product is we're actually working on zero-touch provisioning. So one of the things that I found that was particularly problematic when you start working through Proxmox environments or VMware environments is there's still not a good mechanism in those to be able to do agnostic server provisioning, right? So what we want to basically address there, and what we have addressed in the product, and everybody will see this pretty soon, is that our product allows you to basically go out, discover assets in the rack based on current available BMC methods, which are IPMI, there's Redfish, there's a few others. And then that allows you to securely connect into that BMC, discover that, and then actually provision our Keras hypervisor on it without having to do a bunch of manual work or log into an iDRAC or an ILO and deal with all that stuff. It just makes it much easier. So what we've done there is we basically have built two constructs there. One is you can connect to it, and you can do it through what we consider pixie-less, where it actually mounts to the virtual media on the server, and then allows you to provision the Keras hypervisor. And then the other one is it actually does it through standard Pixie boot. So what we've done is we've integrated a built-in DHCP server into our product that allows you to effectively Pixie boot and then go ahead and instantiate a hypervisor footprint on hardware of your choice. And that's the big thing that we've been focused on, completely agnostic. We don't want any vendor lock-in. Bring your own hardware. Customers can use basically whatever they want. So that's a big push for us. The other piece that I was going to say that's pretty important is also lifecycle management for those servers. So when you do provision a server and you do put a hypervisor on it, there will be people that want to do things like firmware updates, and they want to set a specific BIOS profile that enables things like SRIOV, and other options in there. If you're doing PCI pass-through, you might want to enable things like ARI and resizable bar and all these things. So those templates can actually be injected in through those methods that I mentioned, and then that becomes part of a workflow where essentially you have one step completes the next, there's a callback, goes to the next step until you actually get the server completely provisioned and configured to your exact need for that specific environment. So we're trying to address that whole server lifecycle as we go through that. So that's actually in great shape. We have that done. So you can deploy the hypervisors very simply, and you can also maintain the life cycle of the servers. Any questions so far on that? Okay, perfect. So what we have effectively done is, like I mentioned, is we built a very similar type of product. If you look at it kind of like from Proxmox standpoint, you have your typical data center, you've got your nodes that are underneath that. We support all of the external storage capabilities like they have. So you'll see S3 and iSCSI and NFS and PNFS and MooseFS and CPUID and all these things are effectively in there. So when it comes out, you'll be able to mount to all those and use those. We upstreamed the fixes for CPUID recently. So now the CPUID filer does actually work within BSD, so you can use that as a distributed file system. There's still a few CPU contention issues we're dealing with there, but for the most part, it works pretty good. There's other parts of the product that we are very much similar to what you consider a Proxmox as well, where we're going to have a fully functional SDN. And part of that is, you'll be able to do all your internal routing. So we're going to support, BGP, OSPF, all of those. So you can effectively build what's akin to an Amazon, VPC. You'll see security groups, ACLs, everything that you would effectively need to connect the hypervisors to more of a distributed switch type of framework. And with that, we actually have the ability to, and we will very shortly, to do specific things with the SDN that allow, kind of like more of a spine leaf or mesh type of architecture. So BGP is very important in that. And then we've also built in a complete PF automated framework. So you can go in and there's a nice GUI in there. You can add, remove, change options within the PF configuration and all of that. So that's there. We support VXLAN, Genevieve, a bunch of other stuff. So it's becoming a very complete solution. By the time we release it, you'll see the fully functional SDN on top of that allows you to do layer 3 functionality with the Bhyve hypervisor. We have built out functionality around Veil. So you can go in, you can use a Veil virtual switch. We have the standard virtual switch concepts. All of that works. So all of the networking constructs are there. We're doing some work with vector packet processing and DPDK as it pertains to lower packet latencies and throughput. So we've got some interesting stuff going there that's not probably going to be in the immediate release, but it'll be in the future. And then we also have been very much focused on ZFS, right? So ZFS is a first-class citizen within the hypervisor, and the focus really is, anything that you can do at the advanced configuration at CLI level, you can do in the UI. We also have it available through the API. But the intention is, if you want to go in and do an L2 arc, or you want to set up a separate, slog, or you want to go in and build something like that, it has the functionality for that. Compression, dedupe, encryption, all of that's built in and functional within the product now, and you'll see that on release. And then we also are working on a clustered ZFS solution that allows you to horizontally scale ZFS. That'll be part of the product release as well. Not this immediate one, but pretty close into the future. And then lastly, the piece that's probably most important is we've extended a lot of the functionality out into the product that really kind of has further reach into the data center. So we created our own data center information management framework that allows you to essentially go in and add rack level devices, PDUs, power panels, power paths. We have an IPAM that's effectively built into it where you can do that. IPv6 is going to be added into the product very soon. And we also are going to support, telemetry from critical data center infrastructure. So if you have let's say a crack, and you want to make sure that you're monitoring the functionality in that and temperatures and fan speeds and all that, you'll be able to pull that in through a standard Redfish API that then allows you to monitor those aspects in conjunction with the hypervisor. So really what we're trying to build is not just a hypervisor environment, but we're trying to build something that's much broader reach into the data center that actually gives you some useful telemetry, but also allows you to control different aspects of that environment. So as an example, if you want to control a Tor switch, we're going to have functionality to be able to do that through your standard netcom for your Yang models, where you can go in and set VLANs on switches and things like that. So it's a fairly comprehensive solution. We've been at it for pretty solid, for, like I said, 4 or 5 months. We've got about 22 developers right now that are working on the product. Chuck's on the team, which is great. He's definitely seasoned in the FreeBSD, development space. He's been doing some really good work with us. We just onboarded another individual that's helping us with some of the clustering pieces, which we're starting to aggressively work on, and we'll have a clustering model that's effectively built out that's going to be native and functional within our product, in addition to things like live migration is planned. So the intent really is with this is we want to finally get to the point where FreeBSD is a first-class citizen when it comes to competitive hypervisor, and then also a competitive hyperconverged type platform. I don't like that term because it's too overused, but when you want to consolidate storage and network and everything into one product, that's really going to be the intention, with it, and use that at the core, right? So that's kind of a quick summary. I guess I'll stop there if anybody has any questions. Like I said, I'd love to be able to show more of a demo. We're just not ready at this point. I would like to be able to show it in its complete form. So perhaps, Michael, what we can do is set up in coming weeks, we can set up a separate session, and I'm happy to go through some of that and show everybody kind of what we have once we get that to a state where, I can reliably show a few things and we're closer to the actual POC release date. Yes. Mm-hmm. So right now, as it stands, we're using, so for BGP, we're using Bird is what we're effectively using, which is part of, so everybody's probably familiar with the FreeBSD RP project, which is, I think, Netflix runs that. So a lot of similar approaches. He's got a fairly comprehensive solution that he's built around BGP that uses Bird. And then Quagga, and basically Quagga for the actual CLI. It's the CLI and then the iOS equivalent type of functionality and control with an API that we built. Yeah. Yeah. Okay, so great question. So yeah, absolutely. So so the open source stuff we're going to announce in probably the next week. We're working on that piece, but the intention is the core hypervisor itself and all the functionality around that is going to be open sourced and available into the community. It's some of the value add pieces around it, you know, that will probably, we obviously have to be able to monetize on it, right? So there will be some of those pieces that we have as supplemental, and then kind of what we do similar to Proxmox is, you know, there's a paid support tier model, you know, where people buy that and then they would be able to leverage that, but use the product, you know, in an open source fashion. So everything we've written in Go, it's relatively simple in that respect, is that we built everything kind of from scratch. There's really not a whole lot that we started off with. We did use a little bit of the Bhyve framework, and we're working through some of that, but we've changed that pretty drastically. So some of it will be familiar, but the intent is, yes, we will have an open source version available that people can consume, use, and then, you know, modify at will with the value add kind of like ecosystem around that, a product that we've effectively attached to it, is the idea. On the AI side of it, so this is where I tried to be a little bit careful with this, because I don't want to be one of those companies that overuses AI and just, you know, saturates everything with it. But we do have some compelling technology that we built into it that's very much focused on like kind of like almost like a RAG model, if you will, that allows people to go in and make some queries and kind of deterministic type of infrastructure provisioning, if you will, where you can go in, give it specific criteria, and then that will go in and actually, you know, identify things, help you effectively allocate the assets, identify the assets, do certain configuration things that are fairly mundane and fairly painful, to try to facilitate that without actually breaking your infrastructure and destroying your infrastructure. So we've boxed it in, and we have very specific use cases for it. But when we use AI in context, that's kind of where it comes in, is that it's kind of like intelligent, you know, data center awareness and some provisioning aspects to it that we've built into that.
Did you say RAG model?
Yeah, so basically,
Can
like
you elaborate
an agent.
on that, what that means?
Yeah, well, it's kind of like an agent, if you will, or something similar that allows you to basically ask the platform to go in and identify certain pieces of infrastructure, if you will, and then do certain things with it, and kind of almost like build you more of like an automated type of workflow, if you will, without having to go through that and go through this long process, you know, of trying to identify infrastructure, all these manual things. We're kind of bringing that into more of a fully automated approach, where the system is kind of aware and it knows what's out there, and it can present that stuff back to you, so you can get the workloads as quickly as possible. One thing I was going to mention is we are supporting, and we have built in a complete Kubernetes deployment model within the product, so you can actually go in, you can deploy multiple different Kubernetes models. We have implemented cloud into the product, so we support that fully. We have a distributed storage, block storage model that we're going to start working into it, that we've started building. So yeah, there's a lot of stuff in the works, so with a lot of it being completed, but for the first time, we're kind of like, I'm kind of seeing like, wow, you know, this can actually be, you know, a Bhyve-based hypervisor framework that can be used for enterprise consumption with a support team and global reach, you know, and the support to be able to, and the funding and everything to be able to back that. There's a substantial amount of funding behind this project.
All righty, we have another question coming in hot. Nope, okay, moved on. And thank you, Chuck, for explaining that RAG is retrieval augmented generation. That's a new one to me. Maybe everyone here is familiar with that. Oh, Dave is familiar. He's a cool kid. Other questions? Yes, Tom.
I have a strong interest in VPP, and I was just wondering what has their experience of being with integrating VPP with FreeBSD. Obviously, like it would have been a Linux project or
So Tom has moved a packet or two over the years, and he would love to know about everything about your experiences with VPP. Is FreeBSD a first-class client? Are you missing features? Is it painful? Is it awesome?
It's a great question, and the answer to that is absolutely no changes with that. We actually use, whatever the current branch is, and we test with all of those, and we build upon that so that the fundamental base operating system itself is always going to be, FreeBSD and what it is at its core, with the intent that we use everything that's available through the release cycles that are basically planned and pushed into the community. So yeah, 100% on FreeBSD.
Thank you. Hi, Chuck.
Tom says hi to Chuck, and I don't know to what degree I can wiggle this sucker around, but yes, gang's all here.
Hey, everybody.
Thanks very much. Appreciate the answer.
Thank you.
Other questions? So basically, I'm hearing watch this space. You are diligently trying to boil the ocean in awesome ways. It's like, alrighty, you're biting off a bunch, and that's pretty cool. We've got a big team.
It's interesting because we have, and it's a different shift from what I'm used to. Usually, you kind of attach to a few FreeBSD developers here and there, right? But what's really interesting about this particular company and project is that we literally have, a little over 20 FreeBSD centric developers. I mean, that is their focus. That's what they do all day. That's their full-time job. So we're very much excited to continuously push this forward and move it in a way that is going to speed enterprise adoption of the Bhyve hypervisor specifically. I love it. I've used it. I think there's a lot of potential in it. As a company, we want to try to do that and enable the community and push something out that I think is going to hopefully beat the heck out of some of the other stuff out there. When we get to it, when we get to a good point here.
Repeat them. Yes, what's your question?
Okay.
You can read lips.
I'm not sure if that's a proper question, but where are you getting investments from?
If you can reveal where you're getting investments from.
No. So I can provide a little bit of detail on that. It's all private investment. We're not working with any VCs at all. So that's obviously great because we kind of control our own destiny in that sense. But yeah, it's all private investment. I can say that much, and we are fairly well funded into the foreseeable future. We'll probably be just fine without VC, with any type of VC injection.
Is it Chuck?
Oh yeah, you know it.
Are you the investor? You wear it well.
It is not Chuck. It is very much not Chuck.
Not me.
Yeah, and I don't.
Silent partner. You've been very silent.
Yeah, and like I said, Michael, I don't like these type of presentations where I can't show a product that's driving me nuts. But I want I want to show it, and we will. I apologize, I can't do that, but trust me, in the next week or two, we'll get it out there. People will start to see what it is and what we're doing, and how far it's come along. It's an amazing product. I am just absolutely shocked at what we've been able to do in about a 4 or 5 month time frame.
Yeah, no kidding.
So pretty exciting.
So we'll have to have BhyveCon Vegas with the with the hall upon hall and booths and geez. Okay, I guess I'm game. Other questions? Yes, Katja.
I wonder if you work with Fudo for PAM or not?
The question is, are you working with Fudo for PAM? Is that the Paweł Dawidek's project? Yes, it's the Fudo security tool.
No, we haven't. I'm familiar with it, but we have not. And that actually, come the next summit that's at NetApp, that would probably, I know he's always there, so it would be a great opportunity to have a discussion around that, but that would be fantastic.
And is that November? Do you have the dates handy? Because that is a great little event in the Bay Area.
It's
Yeah,
been
it's really, really good.
surprisingly good.
And,
good work.
and by the way, I don't know what the plan is, Michael, but we're, hopefully we can present, we can actually show the full solution there. That's kind of what we're aiming for, but I need to work with the foundation on that, so.
I'm sure they'll let you in the door.
Yeah.
So, wow, exciting stuff. Join the calls, as I've been telling each presenter. Yeah. Don't be a stranger.
Yeah, we've been a bit in obviously stealth mode because you know how it is. It's just competitive wise. We want to make sure we have that advantage, and we also get FreeBSD out there as like an instant like value add. Without we've been very careful in that. We just want to make sure it comes out and we hit the market like in that wow factor. Like, oh my gosh, Bhyve can do these things. Absolutely, 100%.
Well, anything else? Well, thank you so much.
Thank you. Appreciate it. Thanks, everyone. It's a pleasure to join the chat. Thank you for having us.
And I encourage you to watch the stream. We'll probably take a break right now, and we'll just get into some user stories.
All right.
Take care. Bye.
Thank you.
Thank you.
All right. Bye-bye.
Break time. Thank you for your patience on all that. We've had a whole lot of material. It is 4:08, maybe about 4:25, just 15 minutes plus a little bit, just to stand.
Yeah, when Windows 10 is up and running.
Yeah. Joran is working on his slides and won't be here. Patrick Housen, you have what, 15 minutes of topics? Perhaps, hold on, I'll go around the room. Let's make a little schedule here. I've got my fancy little thing all here. Jan, did you want to talk about jaily things and upcoming features? Or did I touched on them in the intro? Yeah, okay, fine. Clustering and distributed file systems. Let's just say it came up a few times today. It's a hot topic, but I'd like to go slightly unconference. What are hot topics on your minds right now? Although Stefano, we could probably beat up on Proxmox together, but maybe that's not too taktiski, as we say. He's just smiling, so political. Okay, they didn't refund me on a charge that wasn't supposed to renew. And unnamed people have been like, hey, Proxmox, we're not streaming, are we? Who wants to go first? I know we had some little monologues. Housen, do you want to hop up and talk about your goodies? I need like ZVault and friends and stuffs.
Do I need this when I go up?
So here's the hot seat. Patrick, I guess cover us somehow. And I'll take some notes on the main dock.
Hand me over that USB-C thingy.
Oh, you want to present? Okay, goodness, that's here somewhere. And the transition between them was not the most glorious.
Pull your HDMI cable.
Can you take HDMI?
I have HDMI or USB-C.
He has HDMI. Small challenge. You might have to snuggle up closer. Oh boy.
The SDI cable is long enough, so we have a bit of a wiggle room.
Cool. Okay. So yeah, we'll just play it by ear. Just if something pops in your head and you want a question answered, let her rip.
Alrighty. So
And we've forgotten about the stream. Are we streaming good, sir, back there? Okay.
Fantastic. So I've been in the somewhat little bit of an inner circle of the guys who were early adopters of the Sylva project and provided feedback on the Discord.
Your microphone. Ah, yes, speak into the mic.
I speak into the mic.
Cool.
I started.
Yeah. Do you have a name?
I'm Patrick Hausen. I run FreeBSD for hosting services with my company, and I'm a serious home labber for my private amusement. I have lots of hardware at home and experiment with new technology. And I have a host running Sylva, and I have been very active on the Discord where the development and feedback and testing happens. So this is my Sylva system at home, and I have two VMs, one Windows 10 and one Windows 11. And I have just reload the screen because the graphs don't update quite frequently or reliably enough. Now, just watch the CPU usage here. Don't be confused by the graph. This is 1% is the top line. So having auto-scalable CPU usage graphs is a very, very bad idea. They should be nailed down at 100% at the top because it's absolutely useless. I don't need to know if it's 1 or 1.5% or 2 or something. OpenSense does the same. It's stupid. Sorry. And okay, so this is a Windows 10 VM. It's booted. It's just idling around and waiting for a remote desktop connection, which is how I use virtualized Windows. And now the very same thing, same hardware parameters, 2 cores, 4 gigabytes of RAM. Only difference is we have an emulated TPM module here in the Windows 11 VM that doesn't show up in the UI yet. Yep, that option is only available at creation. And the CPU usage is around 30-ish, oscillating from 10 to 40, 24 times 7. It's never really idle, and I have no idea what the operating system is doing. The Windows guest thinks it's idling at around 10% across all cores, sometimes less, and Bhyve, the Bhyve process, I can show you the top. So you see 2 Bhyve processes now. Guess which is which?
One is Windows.
Both are Windows. One is Windows 10 and one is Windows 11. And apart from that, absolutely identical. So.
Windows 11 is 200%?
Yep.
Doing nothing.
So we need to find out why somehow.
But I'm not sure if that's a Bhyve problem. I've seen similar behavior from Windows 11 on KVM as well. Because the VM was completely fine, then it was upgraded from Windows 10 to Windows 11, and then it was stuck at 100% CPU usage.
Right. So for the people in the audience who don't run Windows at all and are not very much interested in this, Microsoft introduced a very, very clever feature with Windows 11. When you boot Windows 11 on your brand new machine with all these requirements, TPM and certain CPU extensions, it doesn't really boot Windows. It boots the Hyper-V hypervisor and then runs your desktop Windows inside that hypervisor, so the hypervisor can provide certain memory protection features that are not available on a bare metal system. And that's the true reason why Windows 11 has such huge requirements for new hardware compared to Windows 10. It's all about that memory protection stuff. I don't know what it's doing.
That's a good point. Did I see an Austrian hand Kiwi back there?
On KVM, on Proxmox, out at home it runs. I need to switch on nested virtualization and it's slow as molasses. Bhyve is with. Bhyve is much faster.
Okay.
This installation here, but then
features are kind of optional if you don't do nested virtualization.
So, just for the protocol, we need to dive deeper into this after the conference. And then a short update for those who didn't get the memo. IX Systems pulled the rug under FreeBSD-based TrueNAS. They released TrueNAS Core 13.3. This is the last edition we will ever see from them. It runs on a FreeBSD 13.3 kernel. And that's that. You can, up to today, run FreeBSD 13.5 jails on top of a 13.3 kernel, and keep my fingers crossed, need to talk to Colin about that, as long as we don't have incompatible ABI changes inside the Relang/13 train, you will be able to update to 13.6, and maybe that will be the last release we will see. There will definitely be no TrueNAS Core with FreeBSD 14, 15 or anything going on. They're gone 100% Linux. And there is a community fork that started in late 2024 called ZVault. So let's go to the code here. So starting page, and the problem is I have no clue who is behind this. I really don't know the people. I have an email address and that's all. And the guy goes by the name JT, and I have no idea what name is behind that. And they act through a ZVault account on GitHub. This is ZVault IO up there. And that's it. And they say they need their secrecy because they fear that IX Systems will sue them and whatever. So they posted a release of ZVault in February, and then they got a friendly letter without the lawyers and everything, just a friendly letter from Chris Moore, the CTO of IX Systems, that there were still IX Systems copyrighted files in there, and please remove them, which they did, and then they issued a second release, I think in May. Yeah. Well, it runs, it's TrueNAS Core, it's okay, but communication is awkward. The community discussion and communication takes place in GitHub issues, abused as a forum, whatever. And now they started to post in, wait a minute, not the README. Where's the, why don't I see this at the moment? Where's the source tree? Yes, thank you very much. They posted this on main, of course. I overlooked that. So here's this post directory, and here's a message from July to the community, what they achieved so far. So they switched the repo from IX Systems forked FreeBSD source tree to upstream FreeBSD, fixed boot creation, updated ZFS, updated the bootloader, etc. But there is no roadmap or anything. Sorry, so I can't say anymore. That's the current state of affairs, and we'll see if Sylva is going to overtake them on the fast lane or not, or carry us, or who'll be first to get production ready. Thank you.
So, on the topic of just that Windows performance weirdness stuff we're seeing across the board, if one had a whole bunch of caffeine and a machine, would they jump to dtrace? Would they watch just in Bhyve CTL, count the exits? Or perhaps, Hans, any thoughts, any ideas? Jan, who has a mic up here? Someone, I don't know. Oh, yes, thank you, Albert.
I would like to prepare a system till tomorrow. And then Hans or Jan, we can have a look why I'm not able to install it. Windows 11, standard installation.
Without NVMe during installation? What's your storage device model?
I have no idea. I have to look at it. I tried it 2 months ago.
Okay.
I will see. I will see. Then I will come to you. Maybe Hans, I first check with him.
That's operating. I can help with that.
Okay. No, then okay, perfect. No, I will contact you tomorrow, and we have a look at it. Perfect.
Cool.
Thank you very much.
Sure, and I'm happy to show you my Auto unattend XML installation where it's just a 2-step process and it's all automated, and I never want to see an installer again in my life. Did I say that out loud? So.
It's the only somewhat bearable method of installing Windows.
By not seeing anything. It's great. So.
Windows is really supported reinstallers?
Any topics before we dive into software networking and the good, the bad, and the ugly?
What about the question before that?
Yes, please. There's a in stereo. I like it. Okay.
Yeah. If you give me another one, I can play the drums. Does Windows 11 require TPM these days? And if yes, does Bhyve support software TPM? Yes? Cool. It's not in vain that I
The answer
put
is yes.
it.
Pass-through and software emulation.
As somebody who ported software TPM, I'm really glad it's put into good use.
Do you prefer beer or caffeine or whiskey or Rocky here in Croatia? Yeah, talk to this guy.
And I can say cocaine, right?
Preferably not. And there are plenty of appropriate Deadpool quotations for that, but they can also wait for the evening afters. So, on the broad topic of software networking, did we call it? Software network performance. What would we consider our greatest pain point on FreeBSD? Everything on illumos seems to work great, and it's embarrassing. And you have warm towels and candy mint on your pillow. And so, Jan, did you bring this topic up? Albert? Dang.
So, as probably most of you have found out, the VirtIO net implementation of Bhyve in FreeBSD is not that fast. 1 gig is not a problem. A few gigs, okay. 10 gigs, and you're pushing it, unless you have very high clock rates on a low core count CPU. And beyond that, it just isn't usable, with normal MTUs that is. And you're either forced to get SIOV working, which means you will never do hard live migration and stuff like that, or we need some better implementation of software bridging and the device model for the power virtualized network card.
What, you solved it on OpenBSD? And
So I'm not using FreeBSD, but I'm using OpenBSD on Linux. So the OpenBSD hypervisor is really slow. We don't talk about that. But we have tried to optimize the client part of the OpenBSD stack by doing VirtIO mostly compatible with the Linux, and there I get above 50 gigabit, 55 gigabit throughput TCP. The things we do there is we do multi-queuing, we do checksum offloading, and we do TCP segmentation offloading.
Of course.
And with that's the number I get on a 12-core AMD machine, and I have 4 cores for the OpenBSD guest and 4 cores for the Linux guest.
So FreeBSD can reach similar numbers as a guest, because the guest driver is there. But the host side of Bhyve, inside the implementation of the VirtIO net power virtualized device emulation, that is what we took the shortcut of having a single queue device with no batching and no TSO-LRO support. And if you really want to torture your system, you can take 4 of them and put them in a link aggregate. And I've tried it. Yes, it works. Then you burn 4 CPUs doing lots of context switches.
Jan, are we talking about throughput between Bhyve VMs on a single host? Does it affect single host, or if it pushes to another host?
Both of them are a problem. The solutions may be a bit different because you can optimize for one or the other. Right now, we're not really optimizing for either. The fix to your performance problems, the easy one in production these days is get proper hardware, use single root I/O virtualization, and pass through virtual functions. Then performance is great. But the problem is that the way the configuration of single root I/O virtualization works on FreeBSD with the IOVCTL tool, every time you change anything, you reconfigure the whole physical card. So you must stop all guests on jails using it, or whatever you're using your virtual functions for, because they will all be destroyed and recreated every time you change something. So if you want to say, this virtual machine must only use these VLANs and this MAC address, and you want to change that, at runtime you have to stop all other virtual machines on the host, basically reboot the host, which makes this unacceptable for certain production users who need this level of enforcement by the hypervisor.
I think that happened to me. Does it apply when you change the IP address of the host, means all the VMs become inaccessible?
No, that shouldn't happen. It's if you want to add another paravirtualized device, change the number of queues on a device, change the required MAC address of a paravirtualized device, set whether or not the virtual machine is allowed to configure the NIC to be promiscuous and stuff like this.
And
these settings you do via the IOVCTL command. And that always completely reconfigures the device as it's currently implemented.
And NetGraph doesn't solve this. This NetGraph implementation of networking.
Oh, a NetGraph is another way you can, so our VirtIO net device emulation inside the user space Bhyve component has different backends. One of them is NetGraph. It has some advantages over the TAP or VMnet pseudo devices. There's also the option of using other backends. I think you can, at least in current now, use a NG device as well, because that's very similar from the behavior to a TAP device, just that it does not go to the normal network stuff, but to NetGraph. And the problem here is that there is no multi-queue support, no batching. Basically, we do a VM exit for every packet, copy it over via memcopy between 2 ring buffers, and then return back, go back into the guest. Think of it as using an NE2000.
Entrene guests, are you talking about SRIOV and all of that?
I just did.
Yes.
Before that, the hardware fix.
Yep.
But again, with the SRIOV being not effectively runtime configurable, it is only an option when you don't need the hypervisor to police the network traffic.
It also has some downsides because you then need to do things like LSCP in the VM if you have failover and some other problems.
Yes, I would say because then you also have to pin the memory of the guest. Because otherwise you can't have pass-through devices. So yeah, there are trade-offs there.
And sometimes you run into firmware bugs in the network card.
Okay, but then you have a bad network card or driver that's not inherent in the technology.
Good news, everyone. It wasn't me. I suspect it's someone in the audience. Tell us more about performance of Windows 11. As everyone gravitates towards one person. Oh, wait, no. Oh, clearly that's Antranig, eh? Do you want to join the Zoom call? We could do Zoom again. How about that? Anyone is welcome to join the standard Bhyve Zoom call. We've got, I guess, Ian hanging out. Really? Okay, we'll see where this takes us. No one's owning good news, everyone? Performance using Windows 11 on an N150 and Bhyve is actually fine. Well, performance or overhead?
As I said, performance is okay. It's just idles at 30%.
Idles it? Well, okay, so it's the overhead of idling at 30%. Well, yeah, okay.
What happens when you set the hypervisor string to KVM?
I can't do that in Sylva, so I haven't tried it. Okay. Yes.
On the host, you could rebuild Bhyve, of course, because.
I was wrong about that one. Actually, you can set arbitrary parameters for the Bhyve in Sylva because Sylva relies on libvirt, and you can use virsh edit virtual machine number and edit the XML and then fire it up in the UI, and the UI won't interfere with it unless, of course, you do configuration changes. So we could try that.
Well, you've got about 50 more minutes to try that. Other fun topics. Yes, Hans. Come here.
Sorry. So, can you hear me? Regarding that Windows issue with the 30% idle usage, one thing that could be related is time counters. A couple of years ago, we were talking about implementing KVM compatible or Hyper-V compatible time counter support, specifically for the benefit of Windows, because that way we can get rid of a lot of VM exits. So in case of that 30% thing, I think the most sensible approach would be to, well, fire up dtrace and figure out what is the Bhyve process actually doing, what's Windows making it to do, what was the reason for the VM exits, and then maybe we can point the finger to the right place. And regarding that other subject, virtual network performance, if you want to hear it, I can try to explain a bit what illumos does,
please,
as I've started before. So the basic idea of word IO net is, as with any word IO, you have the word queues for a communication between the driver in the VM and the device on a host, which is the Bhyve user space process usually. And this is just, if you think about it, a bit of shared memory. The VM sees it as a PCI bar, and the guest knows where guest memory is. The host process knows where the guest memory is, and can just read it and write it there. As I said, I've personally never worked with Viona. I haven't even looked at the code at any time, so I may be talking out of my ass here, sorry. Take this with a big grain of salt. The way I understand this is working is that the user space part is basically talking to the Viona driver and telling it where the word queues are, and maybe waking it up every once in a while, and the Viona driver is shuffling the packets around without leaving the kernel. It may actually be much more complicated than that, but I figure it's something that happens directly between the network stack and the guest state in the kernel, so we don't have the overhead of leaving or copying stuff around too much. While I don't think Viona can be ported, or maybe it can, but it's probably not very useful because it's really tied very closely to the illumos network stack, I think something like that could be done for FreeBSD by someone who knows the network stack very well.
You could. The comparable infrastructure exists.
Microphone?
Oh, sorry. So
Patrick,
FreeBSD's netmap is the closest equivalent. It doesn't do all of what the fancy abstractions in the Solaris illumos network stack can do. we don't have this data link layer, general driver interface, we don't have Crossbow and Fire Engine and so on in between. But NetMap exists. It's a mechanism how you can quickly shuffle batches of packets in multi-queue capable devices through the kernel or through user space. And the problem is right now we have a NetMap backend for the VIT-ONet, but it's still doing one packet at a time over a single queue. So it's basically not much faster than TAP.
Well, in the end, I guess it's someone who knows NetMap can dig into that and optimize the hell out of it. That's what I would suggest.
You would kind of have to pin the memory regions containing the queues so that they're unswappable.
But
and then the kernel could
just a question, is guest memory swappable on FreeBSD?
That depends. It's configurable. So you can have wired memory, so then it's not swappable, or you can have not wired memory, then guest memory is swappable.
I think we don't do swapping or paging of guest memory at all in illumos land. We also don't do memory overcommit, so.
For guests?
Well, not at all, because the general idea on illumos is, or in Sunland back in the day, was that memory overcommit is just lying and causing failures that pop up randomly in places where you don't know how. So just don't do it. Build your machine big enough. Be done with it. And I guess memory is cheap these days. So
you can configure FreeBSD almost like that.
Sure. Just in general, I guess that makes a lot of problems go away on illumos, or just not even appear, that you can have in other systems. But yeah, I guess maybe there's a use case for overcommit that I just don't see.
So the normal argument for overcommit is that if a big process does something like fork and exec, if you don't overcommit, at the moment you fork, you have to now allocate all the physical backing space for it. So let's say you have your 30 gigabyte Java process, it forks, and then you need 30 gigabytes of memory now before you can return from fork, only for it to exec into a shell.
But well, there's refork, and I'm pretty sure there are modern POSIX system calls.
There's POSIX spawn to avoid that if it's implemented.
To avoid it
correctly.
So. I mean, even vfork should exist on FreeBSD.
Oh, it does.
I guess it should. I don't know whether it does. I know that some operating systems have done away with it. I think Linux did at some time. I don't know.
Yeah, I think they brought it back against lots of objections.
I think they both map to the same low level. The fork and the vfork map to the same low level function in the end on Linux, if I remember correctly.
Yeah, it all maps to clone.
Yeah, in the end, I mean, you can do fancy stuff in the memory system so that this isn't a problem. But you just have to do it.
Oh, Illumos folks, there's a question, do you have 9PFS support, be it client or server?
I have seen subcommits when I looked at it yesterday that said something about 9P, but I have no idea. I've never tested it. I don't know whether it's client or server.
Depends which front end. I see Propolis has it.
Oh, interesting. Propolis has it.
Bhyve host does something. We can do something, but we are missing our guest driver, so we cannot mount it.
But we can give it to guests.
Yeah, and I was at some point talking to a guy from the mount people, so we can somehow do it. I think, no, the limitation was we couldn't mount it as root. But we can mount something like a config file in there.
Which, thank you, Doug Repson. There is some basic support for FreeBSD, which is kind of cool. It's like, not quite a POSIX file system, bless you. Neither is NFS. Yes, you can probably reach further back till.
Thank you. Regarding the Podman session, where we weren't able to ask questions.
Ah, yes, that's a great observation.
Is there someone?
As our pod person is working on slides or something, but it sounds like we might have pod person questions.
Yes.
We would love you to. And here's a microphone that Hans is desperately trying to offload.
I'm just a ring in for someone who didn't want to answer questions. Fine.
All right, what? Okay, first, thank you. It's really cool to have something like Docker. On FreeBSD 3 weeks ago, I was using Podman on a ARM64 system, and I used it to install the Selenium, Firefox, and Chromium images for testing. Worked perfect, and now it's gone.
What is gone?
The Podman. If you do a PKG search, Podman on ARM64, it's not finding anything.
Should we have a look?
On
right
AMD 64, Podman is still available. It seems if I'm doing build from ports, it seems that some GoLint package is not supporting ARM 64 anymore. Or so I'm asking, is it coming back?
I'm sure it is because I use it. So
okay, okay.
So,
I'm pretty sure he's trying to use it on ARM64.
yeah. Let me just have a look.
Because
right
I also have to say I am nearly completely switched to ARM because it's so stressless somehow. I still have some AMD 64 machines, but just for testing this platform, this builds.
I can tell you if it's going to come back in the near future. Just looking into the future.
Yeah, so I was doing some Bhyve on ARM testing, and I thought, I'll try tmux and the required U-boot. And they weren't there, but they're being like built. And they'll be built when they're built, and wait.
Okay, another question, if I have the Bhyve ARM.
So hang on a second. Yes, they're coming back. I have them here.
Woohoo.
Here we go.
Okay.
Hey, they're coming back.
Yeah.
Okay, I just wait. Okay, perfect.
Yeah.
And not related to Podman, but Bhyve on ARM64. Is it possible, because now for my ARM64 builds, I use Mac OS on a Mac Studio. Can I install FreeBSD on a Mac Studio?
I use this stuff like every day. So
oh, perfect.
so it works. Oh, sorry. I use that stuff every day, so it works.
Okay.
I just tested it this morning, yesterday,
on
on 15.0 Alpha 3.
Perfect.
And it works.
Okay, great, thank you.
So you need an M3 to get nested virtualization in QEMU, but then you can even use Bhyve inside of UTM.
Kind of cool. Yeah, and it's fast.
Yeah, I would prefer running a FreeBSD directly on a Mac, on a ARM Mac. That would be really perfect. Thank you.
Yeah. Exactly. I was going to say you should run OpenBSD.
I run OpenBSD on routers, but if I need, thank you.
M1, M2, M3. Yeah.
You don't have
You have to use a USB network.
Microphone.
You don't have graphic acceleration, you have graphics.
You need a USB network download?
I think we fixed that in Hackathon in August.
Not a slip connection? Yes, Micah.
So, let me ask the unpopular question, and it's just informative, but how far are we from running Kubernetes on FreeBSD? I know.
I'm dodging that one. I have no idea.
The reason I'm asking, I know there's a lot of work put into it. I just don't know where we are.
Yeah. So, rumor has it that Doug has this running in his home lab, which I sort of imagine this vaguely Google Borg-sized infrastructure, sitting under a desk, probably with a cat on top. But I believe he's been working on this, but I don't know what state it's in. And yeah, I would like to know too. Maybe actually, no, I don't want to know about Kubernetes. I think that's not the solution I have in mind. Yeah.
Too late. The Kubernetes illumos port runs on FreeBSD as well. Tom Norlin was porting it to both systems. It is API plain only, so no kubelet. So it does not run the payloads, but it runs your API.
Yeah, so the tooling is here to use it to control a cluster that is
Oh, to
not
be
running.
a cluster.
Really?
That's the cluster backend services. The only thing that it doesn't have is the one that starts jails and zones.
Ah, right. Okay.
So we now have Podman, which I think is supported by Kubernetes as a runner. So in theory, you could plug it together, but you can also use Nomad and Pod to get something very similar.
Yeah, that's true.
If you want that kind of thing.
You still need a cluster network interface plugin.
Luckily, that's the CNI and not the cluster storage interface. So, which means that it's a lot easier to do because it's a simple line-based ASCII protocol you can implement in shell. The CNI provider can be a 200-line shell script to do what needs doing, whatever. Maybe just something shorter if you just want to give it an IP address and put it on as an alias IP on some thing, and then you even get great networking performance if you use alias type networking in jails. If you use VNet enabled jails, you either need non-pass-through non-pass-through IOV devices. So you can just go into your IOV CTL configuration and say pass-through equals false. Then you see the actual devices and can assign them to VNet-enabled jails, like you would the pass-through devices assigned to a Bhyve guest. Yeah, that's possible. Or you have to go the slow route, which is bridge and e-pairs.
I have a question for Podman. In its default form, does it have the same like Docker network capabilities for the jails? And if yes, how do you implement it?
Yeah, so on FreeBSD, what we use is VNet jails. So each jail has its own virtualized networking stack, firewall, and so forth. And in between the VNet jails and the world is a bridge, and you can create multiple bridges if you want to isolate, say, 3 different customers on their own. You'd have 3 VNets here, so 3 servers for each customer, so another 3 here and another 3 there, and then 1 bridge here, 1 bridge here, and 1 bridge here, and they would be their own little networks. So that's how it's currently implemented. I would like one where I can do sort of direct pass-through, and what I found is that this is sort of possible, but there's no definition in the sort of container networking spec for this thing yet. People have asked for it on Linux, and I think when that moves a bit further along, probably we will want to copy paste it. Kind of what I want is to take the networking that I have in FreeBSD and then say to the container, and use this. It's good, I know it. Yeah.
I just wanted to add a small thing to Dave's explanation. You can, of course, have multiple interfaces to connect it to multiple bridges in a single VNet jail. So you can also build routing and NAT and firewalling, filtering, whatever infrastructures and topologies built on top of VNet and on top of jails.
Yeah, so you make a great point, which is you can do all sorts of dastardly, tricky things. Podman has hooks, and the hooks correspond exactly to the jail created phase that we would normally have in a jail startup script, a native FreeBSD jail. And I've used these hooks to pull in a WireGuard interface into the container and to pull in ZFS data sets, things like this. So all of that stuff is possible.
So I have an understanding question. You showed an example file for the container, which you installed a package and later deleted the package cache, but in a different layer. And my understanding is that the layers are immediate container images, and then the you cannot change them in a
I understand what you're saying. Yeah, so when the containers are built, the final layer is the bit that we will publish, and the other bits just disappear.
Okay.
So each step is those people don't match up. That is not Ian Evans. Troublemaker in chief. Yeah.
Oh, doesn't want to interrupt you.
Yeah, so what you typically do is every stage in the Podman build script is a separate jail, and as you say, we have that layer then with the wasted space, but in the final piece, it'll tar everything up, create a new layer, and that's the final piece that we have, so we shouldn't lose it.
Okay, so it's because in Docker this is not possible. If you want to really delete something and make the image smaller, you have to delete it in the layer you're creating the stuff.
Yeah, I might need to.
In Docker as well, but you have to explicitly do it.
Yeah, okay, that's true.
I'd have to go back and look at my notes to see whether I have to do an explicit squash step or not.
Okay.
Yeah.
Okay, Antronik, let her rip.
Inside, sorry. Let him.
He's lurking. Is he joining?
He's muted.
He is muted, yeah. Well, he didn't want to interrupt Uncle DC8. It's very sweet. I mean, aw. That's to unmute.
Oh, well, in the meantime.
Hi. How are you?
What was I going to talk about? Oh, yeah, right, the networking. The long story short version. Maybe I should mute YouTube because I'm going to start hearing myself. Apologies for that.
Yes, you should mute
The
YouTube.
long story short version about the Docker networking is that I was moving a customer from Docker stuff to non-Docker stuff. From managed Docker, nonetheless, on AWS to basically jails. And we saw multiple levels of performance gain. One of them was on the file system level because there's no more overlay FS headache. The second one was on the networking side because they were doing a lot of backend calls into multiple microservices, and having a 10 gigabit Ethernet adapter / driver such as ePair was very handy. And the last one was that developers seem to be happier with GLs. And by the way, I can't hear YouTube due to echo. You can type in the chat when you want me to stop.
You can probably hear me.
Another thing that we also noticed is less CPU usage when it comes to the hosts you're using their CPU. To be fair, I don't know how managed Docker works on AWS, because that's kind of like their secret recipe. But in this case, we were deploying on a fat bare metal, right? So to add on Patrick's point, we can also have, in this case, multiple interfaces with multiple e-pairs, and then you attach on top of that something like VXLAN, and you can run a mesh of networks, which doing that on the Kubernetes land or the Docker land requires a whole black magic of CNI adapters and tools. So, I mean, based on my experience in the last 3 months of moving that customer, it turns out that, and the developers couldn't care less. Like, they don't care about Docker. People keep telling me they care about Docker. As soon as you move them off of Docker, they don't care about Docker. They're like, oh, okay, I can run my Python script, thank you very much. So that makes sense when it comes to like real life compared to tech Twitter. So, yeah.
How about now?
Yes, Mac.
Dave, did I get it right that Docker on FreeBSD is actually package base? Inside the Docker, I mean.
Oh, so the containers for 15 are built with package base, and the containers for 14 are probably also built, actually. I'm just trying to think. I'm not sure off the top of my head. But yeah, by default, we're using package sets for this. Yeah. For 14.3, it must be base images, and we remove files, I think. I can just have a look. So the question earlier was, do we need to squash the layers? And the final build stage, I should have a squash flag added to it to do that. But I don't see a step to do that in the container file directly.
embracing the silence, think about lightning round items. What would you like to see a report on at next year's BhyveCon, where it's like, oh my gosh, we got that new thing. We all want to, yay. Short of faster networking.
Well, while holding the mic and
Yeah, you
holding monopoly over it, I would really love to see the GPU sharing. I personally have wished to use it, but it's not job related, so probably it's not gonna be something that I'm gonna deal a lot with. But I think it would be great to have some less reason to restart into Windows.
Is that one and the same with SRIOV GPU support, or it's something else?
To my understanding, it is something else.
Ooh. Okay. If you've got links, please share them.
Well, not right now. I remember reading that KVM supports it, and that you can, well, it boils down to having a GPU working on your Bhyve, ideally, and your host, so you don't have to choose which one.
I recall Intel having this whole letter soup of GTV, DVD, GB, with some of those being it. Okay, okay.
Sorry, that's the general purpose GPU, if I'm right, which means that you can run some tasks on the GPU, like similarly what we use for the AI currently, but take it with a huge grain of salt, because I haven't read about it in ages.
Okay.
Okay, so just from my want list, one general, one more specific. General, yeah, just hopefully a good successor to Truna's Core, and ideally with really good Bhyve VM and jails management, including some virtual networking stuff. That would be my main wish list point. And the other one, which goes a bit back to the PCI pass-through in the morning, yeah, I want my Intel Arc support. I need my media engine AV1 encoder hopefully everywhere. So yeah, that's I'm really stoked for what's happening.
Which exposure? What exposure?
The Intel's media engine AV1 encoder. Okay. That's something I want to use more extensively in the future, and it would be great to use it from virtualized clients.
Have. Okay, who has funding anonymously here? Jesus.
Not AVX, AV1, the video codec.
Oh, oh. News to me. We're full circle to secret and anonymous. Secret. It's like, haha, psych. Okay, who's got some money? Come on, yes, sir. You've got the money.
I will second the Truna's Core thing, because it has been a gateway drug, and we need as many gateway drugs as possible for FreeBSD. A thing we haven't touched on yet, because I think we are talking bleeding edge, but documentation. How about documentation and Bhyve? Are you the holder of that? Oh.
Shake your head very quickly.
Do we have any thoughts on documentation?
I have lots of thoughts on documentation. It is a gateway drug to becoming a committer, and it is really easy to start. It's really easy to start. You start trying to make something work, and then you fail, and then you write some notes on it. First, it becomes a blog post, and then it becomes part of the handbook, and then it becomes a man page, and then you have, I think it's fame and profit is the next stage. I think that's correct. Open source fame and profit, yeah. But I highly recommend, if you find something is missing, don't just write a blog post. Have a crack at adding it to the documentation. Paradoxically, it's much easier to add something to the handbook because it's just HTML and it doesn't go in a release. So if it's missing, it can be added and it can be updated very quickly. I think the hard part in truth is finding someone who can review it, and add it. Yeah, exactly. If only someone had written a blog post about that.
It's a final blog post.
It's a final blog post, yeah.
The final blog post.
And I think if you've come to one of these conferences, you can leave this conference knowing and finding people who will help you get that documentation across the line. And if you can't find anyone for FreeBSD, you can ask me and I will try and coerce someone into helping. Yeah.
Show of hands. For those in FreeBSD land, the Open ZFS handbook page. It's an introduction or it's a comprehensive enterprise deployment guide needed for full enterprise use. And it came up that, oh, it's woefully out of date. It's painfully out of date. And I pointed out some little issues there. And then it's like, wait a minute, this should be all the things. And yes, Patrick, what is the correct answer on what the heck we do with a topic like that?
I have no idea. I just wanted to elaborate quickly on the out-of-date remark that you made. It's not only out of date, it's dangerously contradicting current best practices. Specifically, it's not adhering to the layout our own installer produces. And we have 2025. ZFS-based root install is the default for FreeBSD, and the handbook should document what the installer does and why it does it, and how you handle replacing a disk with a partition table layout that the installer creates, because that is what all users, new and old ones, will face. OpenSense installs to ZFS by default, just saying.
Was it you who pointed out that a pfSense user logically went to the handbook page and tried to replace a disk, and it's like, let's help you destroy your data? It's like,
not that bad, but it's close.
We're not streaming, are we? Go ahead, Jan.
It's not let's help you destroy your data, it's let's help you test your backup.
Nobody wants backup, everyone wants restore.
Nobody wants backup, I know.
Joking aside, the problem is that the documentation in the handbook was written at a time when the ZFS installation instruction was spread across 3 wiki pages. And the idea was that you could just DD the installer at the magic offset in your devices, because there's like an 8 megabyte reserved space in the pool layout. And that's enough place to put the loader in. And then you can put the MBR in front, kind of boot code, and yes, you can actually boot like that. And if you do a zpool expansion with RAID Z on such a device, your bootloader will be overwritten because ZFS repurposed this space nobody has used in basically all of the ZFS history, supposedly. If you want to read this installation instruction, the dangerous type, you have to look it up in the Wayback Machine because it's no longer really visible in the wiki. And yeah, but the long-term consequences of that manifest in the handbook. It still recommends, as far as I know, to put your pool on an unformatted disk. So the next time you take your pool and boot your workstation into Windows or to attach your external device to it, Windows will offer to format that uninitialized drive for you.
What could possibly go wrong? So I think this illustrates 3 really good points. The handbook is out of date. We have 2 people who know what needs to be replaced. And you have 3 days. You have 3 days. You have 3 days.
Why did I admit to knowing anything?
But all seriousness aside, this is a great place to start.
One point. Benedict went to quickly correct the most urgent mistakes and mention partitions instead of raw disks and stuff.
Yeah.
And I suggested contributing, and then the discussion started if this ZFS handbook section that is titled Starting with ZFS or Discovering ZFS or something should really cover production operation of ZFS root-based systems, or just discovering ZFS if you have a new disk to toy with and install ZFS on it. And here we are. That decision has to be made before we put serious work into it. Apart from that, Michael already went ahead and put together a rough draft of the information that should be in there. So we need to decide what the handbook should cover and in which structure it should do that.
Did Benedict use disk labels or device, proper modern-ish device name?
Modern-ish device.
Yeah, well,
So
labels are a very
GPT.
good approach for various reasons.
So I think it's a good idea to give people a handbook chapter or section on learning about ZFS, kind of exploring ZFS, but we need the other one far more dearly.
And do we discuss recovering pools? I mean, how far do we take this? And
So-
is this a ZFS project problem, which I hear there's a summit coming up?
Well, the pragmatic approach would be to think about how much can we accomplish with limited resources and short time. And ideally, we would cover the stuff that is unique and special to FreeBSD. So our ZPool layout that comes in the installer, for example, how you manage partitions in FreeBSD. And then most of the other stuff, if people want to contribute it, it would be ideal in the main ZFS documentation, OpenZFS, because it would be applicable to all systems. Yeah. But that's just me.
Did I make a terrible mistake by creating a ZFS pool from G labels?
No.
G labels.
No, not catastrophic.
Did you just put a G label on the disk?
Yes. And then create that pool.
So your data is not in parallel, I think. The problem is that if you take your G label disk, only FreeBSD knows about G label. So
That's
if
fine,
Windows
fine.
sees that, it thinks there's no partition format I know on this disk, neither in master boot record or GPT partition table. So it will think it's an uninitialized disk, and both Windows and Mac OS will offer to do the initial format for you. And that will, of course, override the important metadata at the beginning of your disk. And then if you start using it, your pool will be destroyed within seconds.
No, because back in the day I was doing it by the handbook, which was directly from dev device, like what was it, ADA 0,
Or ADA, right.
or whatever,
Sorry.
DA, yeah,
DA.
never mind, yeah. So what I did at one point, my disk got out, I rebooted the server, and then all those DAs got mixed. So that's why I moved to G labels. What is the better way to do it than with G labels?
So ZFS doesn't care. It will probe the disks and find ZFS labels inside of them at specific offsets, and if it finds them, it probes the disk and sees if it can assemble a complete pool, or a degraded pool at least, from it, or if it only sees the remains of the pool. And if you have one disk out of a pool, it's probably not enough to pull the pool up.
They have nice things,
So
a lot of them.
Only on FreeBSD, always it's okay to use
Toasterson. Toasty.
Yes.
So how big are the...
Portable, a GPT label is a bit more, because that's a bit more portable. If you at some point have to import it on Linux or Mac OS or whatever.
So the proper way to do it would be to, on new disks, type gpart create-t dash f for schema GPT, and then gpart add -t ZFS, maybe an alignment of 1 megabyte.
This is true, but the partitioning and
We no longer want to use raw disks for ZFS. We want to partition it with GPU.
We never did.
We never did. The reason why ZFS recommends this is
Why
that
do I read about
well, the problem is Solaris, back when ZFS was written, needed the disk write cache to be disabled for UFS. For reason. So if you have partition table, Solaris disabled the write cache of the disk, which throttled ZFS performance massively, because ZFS is able to use a disk with a write cache. So how to create a pool of Solaris back then was you put the
Should we
pool
give him a
of
microphone?
and then you get the full performance. Otherwise, the disk write cache is disabled.
This man has no microphone, but it's all good.
I don't have a question. I was working on a bug with ZFSD that it didn't bring the disks back into the pool when they are replaced. I read so many things, went through the GM.
I can talk with the microphone.
The what is what?
The voice of God. Oh, Rob.
It wasn't me, it wasn't you.
Yeah.
It wasn't me. Oh, that was over. Hello, Zoomster. Yes. Hello.
The ghost in the machine. Yeah.
So the problem is that if you replace the drive in JBOD, it will not be replaced actually. Reading about GMs, DevD, and God knows what else, I found out that DevD is not going to issue the event every time. The reason I'm guessing about this, is because it uses select, not some other polling event registration. And in every operating system, standard input, output, and error have the lowest numbered file descriptors, and they're gonna mingle with the devd. Now, if you run devd-n, it's gonna demonize right away, and your problems go away. It's weird, but it works. And what I wanted to work on is write a replacement, not a replacement, instead of using select, using KQ for the devd, but that's not an option because not all devices support KQ. So in the future, I suppose devd should use something other than, well, KQ and select. What else is there? Probably polling.
There's no reason for devd to use something better than select because it's not dealing with a large number of devices or file descriptors. It's basically standard in-out error, syslog, and the character device. So what it is doing is it's reading from the devctl device, which is a device which can only be opened once on the whole system. And then it reads lines of hot plug notifications from the kernel, matches that against its configuration and runs something normally or ignores the event.
I don't have an explanation why that works. I just know it does. I mean, we had that problem in production, and that's how we see it.
Okay.
Well, final thoughts as we wrap up the 10th BhyveCon. Thank you so much for just the sheer energy. Go ahead, final thoughts.
Well, like you've been today, are you the facilitator of different stuff? Because then you could be the facilitator of the documentation. It's sparse, I can hear, like it is with
Wait, practically gesturing, you're asking if I do documentation?
No.
Well,
just facilitate the connection between people that'll...
So there's a running...
Oh, do you have a... No.
There's a running joke on the calls. Save it for the software-defined networking call. Save it for the documentation call. Save it for the KQ versus devd call. None of which exist, but yes, in the next lifetime, we will set another 3 days per week to get to these topics. And... Uh-oh.
Because they only has 24 hours to use the line as well.
I like
Yes,
one final word as far as I'm concerned. Please give a big round of applause to Michael, the facilitator. our chief organizer, and who will probably regret being a people person for the rest of his life. Thank you so very much.
I was the most shy person on the planet, if you can believe it. Well, let's break it into completely informal. We can finish up the stream, we can clean up what we have to clean up, and we'll just meet in front and decide if we cross the way to the dinner there. Serious thank you for all of the passion and the folks like Alexei behind a certain Eastern Bloc who is putting his heart into this, and all these people coming together after all these years of so much potential. And it's just been an absolute honor, and keep up the good work, everyone, because it's every one of you who has some story to bring to the table, especially if you're with OpenBSD or illumos or all these other OSs. And yeah, silos aren't helpful. Monocultures aren't helpful. Thank you, Stefano. I'll just pick on you. You've been quiet all day, but you recently, out of the blue, came up with Illumos Cafe to go with BSD Cafe because, well, they're not our enemies, that's for sure. They're a delight to work with. They have the aforementioned warm towels and mint on your pillow and all the cool things, and crossbow, which is not there to like shoot you through the head with a bolt. But yeah, thank you all. It's just such a pleasure to work with all of you. And thank you, Stream. Thank you, Antranig. If you really were to play it, you could unmute and have a final last word, such as your favorite phrase you like us to use on the calls. This is where Antranig says like and subscribe. Thank you, everyone.